I believe, yes. Okay. Welcome back, everybody, to an update on how the mod is going. I've been working for, God, how long has it been? 2 weeks, 3 weeks? On trying to get the wire system up and running. This has been a grind. A couple different false starts, a couple complete redos. It's been pretty brutal. I'll say that. But anyway, I think I'm getting close to a testable version. So what we have, I've tried to break away from a lot of what other mods are doing and hard coding everything. I'm trying to get away from that. I don't want to put all this work into something and then have no other use for it. So I'm trying to build a wiring system that is extendable beyond just how I implement the wiring system or how I use it. So I have everything under here as Catenary. And then the Catenary mod itself, right? Here's the mod. So just like any other mod system, this is a mod system. Everything in the game is a mod system. The whole game is built on the modding API. So the Catenary mod is literally all that it does is it allows for the placement and removal of wires. That's all that it does. And it might sound easy. It might sound simple. However, it is anything but. It was mind-bending trying to get what I want to get done here. So I started with the basics of the hanging wires. Here's one of my. I have all these in the project for easy access, but the hanging wires mod here. This is all the source code from the signal mod, right? This is the signal mod. So a lot of this system here, I was looking at, and then I found this. So hanging wires mod includes a hard-coded call to the signals network mod, right? This is a hard-coded call to add a connection to another mod, and I want to avoid that, right? I want to avoid this connection, or I want to avoid hard coding it. So how do we do that? Well, the same goes through with removing connections as adding connection, but the fact that this is getting the mod system of the signals mod and it's calling a connection there, I want to say no. Okay, there's a couple different ways to do that. There is basically an interface that I could build in my version. Like, you know, I have an iWire network, iWire Anchor. I could create something in here that would be an iNetwork mod, right? iNetwork mod. But I can't iterate all of the mod systems for an interface, right? I couldn't just iterate through all these every time. That would be a nightmare because there are dozens and dozens and dozens of mod systems. So that kind of eliminated the polymorphism sort of thing with trying to just detect which mod systems are which mod systems implement an interface. So that eliminated that. So the other option available to me is what I chose to do, and that is using events. Okay, so I have two different delegates up here, and a delegate is essentially an anonymous call. It's a what's the technical definition? And the cat was in my lap, so my nose is going crazy. A delegate is like a function call. So this delegate is defining the function call, the pattern of the function call, right? So we have the block position of start and end, the start and end indexes of the selection boxes, the item slot being used, and a callback bool ref is a consumed. Right, so if a mod actually exists that consumes that event, I can set that to true, and it will immediately back out and stop calling a list. Right, so that's a vital thing. Bool ref, that is something in the Vintage Story API. I built the vast majority of this system based on a lot of looking at how Vintage Story actually handles things. So we have these delegates here. These are defined outside of the class, right? So these are well defined, and as you can see, I've been putting a ton of comments on everything, right? So when you mouse over something, you should see. Well, for some reason, it's not showing me this stuff. I don't know why. Anyway, in here, I have an event, public event, on-wire connected delegate. So this is the type, right? This is the type, and then on-wire connected. And the same with on-wire removed. And then in here, I have somewhere, let me find it. I think it's near the bottom. So I have in here a remove connection. Okay. This thing has a bunch of logic in it to determine if it's valid. There's a lot of code that makes sure that it's not going to crash, right? You don't want major bugs and crashing. Essentially, yeah, I'll get into the nitty-gritty details in a second. Anyway, as it gets down on here, it says, "Hey, we dropped some stuff, and here's the drop." So it spawns the drop. Doesn't matter what it is; it's just the block type of that wire, right? And then here, I reference the consumed, and I trigger remove connection, and that comes down in here, and this is actually what calls the event, because I have all of the variables here, and it comes in here and says, all right, if it's null, on wire removed. Remember, when you subscribe to an event, you say the event name plus equals, and then your custom function call, right? So in your mod, you will have your own on wire removed, and then you will plus equals this mod's on wire removed with yours, and so that adds it to this mod's on wire removed, which means it won't be null. It means it will point to somewhere. The delegate is essentially, or the event is essentially, an array of function calls. Every time you plus equals on something, you're adding it to the array of function calls. And there could be one item in there. There could be 100 items in there. It doesn't matter. It will iterate through this list of function calls until the consumed is set, or it gets done with everything. right? And so here we have a for each delegate in invocation list. And the get invocation list is just an iterator through all of the different function calls in that delegate, and then it runs the delegate with all of the set variables, and it's in a try catch just to make sure that nothing too catastrophic happens, or it'll catch if there's a catastrophic thing that happens on another mod side. And then if the consumed, if the value is true, then break. So if this consumed is passed, if it's changed in this delegate call, it'll break it. And that is essentially the thing that calls all of the whatever subscribes to that event. Okay. And then I have on add connection as well, pretty much the exact same setup here. So there's obviously an error logger and stuff if something goes terribly wrong. The one thing I don't have yet is the call to trigger add connection. I am still working on the enormous process of, where is it, on interact. Yeah, I'm still working on this. This on interact is the master function for adding connection. And so there is a ton of cross-checking of code and cross-function calls that need to be made, and logically in my head, this is actually what I'm pretty good at. It's just there's so much to this now that I have to go through this and really take my time, because it is it's not easy. All right, so we have this can attach wire. This is another function call outside of the mod using an interface. The interface is the iWire anchor, right? So iWire anchor is an interface that has all of the valid function calls for determining the connectivity of any network, right? So the hierarchy how would I do this? And feel free to ask questions. So the hierarchy is basically at the very top. I would put the function, the wire function. What function is the connection? Right? So the wire has a function, but also the connection. The point at a machine or the point on a relay of the connection has a function. There is a limit to one function per connection, right? You can't have say your internet running through your power. I mean, you might be able to, but it would be, yeah. Anyway, so each function would have their own network, would have their own separate mod to implement it. But you could have the basis for what I'm doing is I wanted to have a theoretical, way down the road, a theoretical block that would be able to connect to any number of networks. So a block that has a connection for power, a block that has a connection for signal, and a block that has a connection for communication, all in the same block space. So how to do that is there's a lot of shenanigans that have to happen. a lot of separating out of things and stuff. And it's not easy because of how the JSON works and how attributes work and how a whole lot of other things work. Remember, the unique thing in a block, when you place a block, the unique thing in the block is the attributes. That is the thing that you can modify and save with the block. That is the unique thing. So everything that you want to change about a block has to be done in the attributes. And if we look at, if I go down to look at the actual mod assets, vintage engineering. So test machine and test generator. I have already opened. Let me pull this over here. All right. So I'm already working on. I can't zoom this. Really? I can't zoom it? Tweet feedback. No, why is that a button? I want to zoom. Okay, well, obviously they don't want me to do that. Okay, so here we have test machine and test generator. There again, I'm taking the blocks that we started with that I prototyped already, and I'm just trying to add functionality to those as we go. So the test machine and the test generator are basically identical shapes. But they have different functionality. So what I'm doing now is I'm adding like variant groups, a state, right? I'm adding a state and I'm adding a side because I'm adding horizontal orientatable to the behaviors here, which means when you place it, it can be rotated depending on how you're facing, right? I want to figure that out. So that's one of the to-do lists. So the shape by type you can see is a rotated, right? It's the same shape, right? It's the same shape. It's just rotated. So that just takes care of that. So that gives you your north, south, east, and west. The state, on, off, and sleeping, those are ones that I'm also going to have to code for when I get the wiring system working. But coming down to the wire nodes here, attributes, wire nodes. This is a custom set, right? This does not exist in the base game. And this is essentially, think of the wire node or a single wire node as, where is it? Collision box or a selection box. It's essentially a selection box, right? So the collision and selection boxes are based on fractions of a 16th, right? 1/16, 2/16, because a single block can be split up into a 16 different voxels. You know, think of like chiseling, 16th different voxels, and so the collision and selection boxes are usually in groups of 16, and I actually have a little cheat sheet that has all of the segments, right? So 0.0625, 0.125, 0.1875, 0.25, so on. Those are all increments of 1/16. So the wire nodes has essentially that value, x1, y1, z1, x2, y2, z2, represents two coordinates of a cube. One like the lower corner and the opposite upper corner. That creates a cube as you scale it up, right? It creates a volume. And so that actually creates a a cube in the shape that is a selection box. That is a wire node. Now, there's some other details in here. Index, wire function, and max connections, right? These are generic. Generic is just not the right word. I'm having trouble vocalizing what's going on here. Mainly because my nose is all clogged up. That damn cat. Oh. Anyway, for every connection, let me talk about this way. Regardless of what the wire's purpose is, these are values that are relevant to every one of them. Okay? Every wire needs the number of max connections that you can connect to it. And it needs it at a very low level. So the items in this category, this attributes, remember, this is the block. This is the block. So at the very lowest level, the block's attributes are very easily accessible. But you cannot change them to the block. So these are static values that you cannot change for the block in the game. The block entity, we'll get to that. But for the block, these shouldn't change. These should be static for everybody. So our block, if we look, wired block, right? Wired block inherits from iWire anchor. And iWire anchor holds number of anchors in the block, right? So if we pull up this again, number of anchors is just how many in this array, this square bracket here. This square bracket indicates we're in an array of items, right? This is a JSON item, but it's also an array of JSON items, right? So this is in literally index 0. I have it set here, but this is wire nodes of 0, bracket of 0. If we were going to look in there, there's probably a place in my wired block that I actually go through that. But here, wire anchor, right? This wire anchor is this wire anchor right here. So we know wire nodes equals attributes. This is the block's attributes, unchanging. The question mark here is a nullable. It's just one of those, like, if this bombs, if this is a null, if they misspell wire nodes with the capital N, if anything goes wrong, right, this will return null, and it will crash the game if I don't do this. If I don't put these little question marks in here as a nullable type, because it will go into here. This will be null, and then do this as array on a null will just bomb. It'll be like, this is unknown object. As it is, it will be null, right? It's a nullable type. If this is null, wire nodes is null, and then I do a check for null. So don't do it if it's null, because it's bad. The wire anchors, I just say how many are there, right? Attributes of wire nodes. Doesn't matter what's in here. This bracket to bracket right here, right? This is one item. This is one JSON item inside wire nodes. So this JSON object is generic right now. Attributes.asArray. If there was, let's say, a whole bunch of them in here, then this array would have more than one in it, and it would be a whole bunch of them. So then I say wire anchors equals new wire anchor, right? Wire nodes.length. Now wire anchor, this is I've been going back and forth in my confusion on this. Wire anchor has no relation to the interface iWire anchor. They are in the same file, so we have iWire anchor. And I have, again, I tried to put as many comments and as many descriptions as I can in here. But iWire Anchor is an interface for blocks which have wire anchor connection points. It is literally for blocks with this node in the attributes, right? Because the calls in here, get anchor position, get wire connection in block, get max connections, can attach wire. If your block, remember, we have 3 different layers. We have the block, which in the game, when you place a block, every block of that type is the exact same object, the block. The block entity is unique to that location in the world. When you place a block that has a block entity, the block entity is automatically created when you place the block, automatically initialized with all the default values, and then as part of the game as the block entity. It's the thing that ticks, right? The block in the game is static, like it just is. The block entity is the thing that's like ticking. And then we have a block behavior, right? The the behavior system in the game has taken me weeks to get my head around what's unique about that. The block behavior or block entity behavior is extra layers that you can put on top of block entities. And I'm utilizing them in a way where I realize last couple of days I've been fighting with it, because the block entity behavior also has its own properties associated with it. But one thing I learned is you can't change those either. The block entity behavior has properties, and if we look up here, entity behaviors, right in here, right? So again, this isn't finalized, but this is essentially, this is all in progress. But the entity behavior adds a little bit more functionality on top of what the block has in my instance. So let's say you want to create whatever mod that, uses the wire system, right? So you would inherit, there's a reason, if I go to wired block is an abstract class. You cannot declare a wired block object. You have to inherit it, because this is an abstract class. There are calls in here that would immediately throw an exception. Here's one right here. Can attach wire. Can attach wire, if you call this, if you just declare a wired block and you call this, it would crash. It would throw an exception. Because you have to override this with whatever mod implementation that you have. And then you could say, hey, give me the wire type. Give me, it has more specific details. But the base object, which is, I say, do not call base, as it throws an exception. Don't do that, because it would throw an exception. It's hard coded. So it's a catch-all. If somebody implements this class and doesn't do it right, it will crash on them. Anyway, there are certain things that I can do. Get number of anchors in the block is just how many of these are in the block, right? It's every block has a static number of wire nodes, right? That I know. And so you can just return the length. They're all virtual, which means you can override them in your object if you want, but you don't have to. Certain ones are fine. Certain ones are not even done yet, because you can see get wire connection to block. There's a whole lot more to this than we're not ready. We're not quite ready to throw it into a game yet. I'm still working on the base wiring system. Okay, so I hope everybody kind of sees at first what I'm going for here. Now, the next level down is how do you save? Because a lot of this code I'm basing off of the support beam system in the game. And the support beam system is strictly done through behaviors, block entity behaviors. So when you add a beam to a block, right? So whatever block you're facing, when you click to put the beam in, the block that you're facing, right? Whatever block it is, it doesn't matter what it is. Whatever block that is, when you place that beam, automatically the behavior gets added to that block entity. If the block entity doesn't exist, it creates one. So the game forcefully, whatever block you connect to, stores that beam. So the behavior has the array of beams that are connected to that block. And I thought that was a really good way of doing the wiring. I wonder if I could... Okay, let me see. Oh, Paint? MS Paint? There we go. All right. Let me outline... God, that's so bright on my face. Look how bright that is. Jesus. Okay, so we have, and this is going to be the gnarliest, nastiest thing in the world. Okay, so we have the block, right? We have the block. The block is generic wire anchor. So let's say we have a wire anchor set up right there, right? So that's the wire anchor as defined here. This is the wire anchor. The whole block isn't the wire anchor. Just this little bit right there is. So it holds, it has to know what wires are connecting to it. It already knows, it already has defined the max connections. So one connection is all that it has. So the max connections is 1. So if we have a wire, let's change the color here to, say, blue, and have a wire coming in here. There's a wire. So that wire right there, the problem is, let's add, oh, damn it. Why did that change color? Oh my God. Yeah, as you can tell, I'm not a big user of MS Paint. Let's get you back to black. There we go. Brushes. Let me get you back to blue. Okay. And now we want this. Maybe this is on a pole of some kind. I don't know. Yeah. Pole of some kind. Whatever. Whatever. It's MS Paint. It's MS Paint, everybody. Okay. And then we have maybe another wire stretching across. And then we're going to take this one off screen. Right there. Okay. Now, how do you represent this in code? Now, I'm not talking about the electrical system. Just the wires. This is what I've been trying to wrap my head around for days, for weeks. How do you represent this in code? Okay. So what I basically did is, this block here has the wire anchor. And again, that's how we define this. Max connections, the wire function just gets pulled from the enumeration up here, right? Signal, power, communication, other, all, or none. None is a special case that's used in error reporting. If something returns a none, that means an error happened, and I wanted a safe way that didn't completely collapse the whole system. So, like, for example, if you're looking at a machine and not... So the machine will have a selection box, right? A selection box. And then the wire node will have a selection box. If you're looking at the machine, it's a none. There's no wire connection there. Anyway, so what I basically did is, in this instance, we're using behaviors. We're using block entity behaviors. Because imagine this block having a imaginary block entity, and we're going to represent the entity with red, and this is going to be here, right? Okay. So this is the block entity. It's this sort of ether thing that you can't touch, like a little ghost that's there. It's in it's in memory. It's being simulated. All of that good stuff, right? But it's unique to this space. I could have 20 of these blocks. Every one of those is going to be the same exact block, but they're all going to have unique block entities. I'm hoping I'm driving that point home. The block entity behavior is another thing that you can add on top of that. So, behaviors like ground storable, that kind of stuff, those are similar in type, but they're not unique to the block entity. There's not very many block entity behaviors in the game. There's not many of them. You can pull up dnSpy. God, this actually worked. So you can see BE behavior is how it's labeled in the game. So you can see BE behavior support beam. That's what I'm using as my template. My overall, like, this is how this could be implemented. But you can see block entity behavior. There's a few of them in here, but not very many. Right? Block entity behavior attracts lightning. That should be obvious what that does. Very simple. On block placed, right? On light, like very, very simple. Like, it's a lightning rod. It's what it is. Burning, block entity behavior, that is a temporary thing that gets added if, like, you're like me and you burn down the whole farm. The block entity behavior gets added as blocks start burning and then gets removed after they're, destroyed. So the block behavior door, where there's other things I'm going to look at in here, but essentially this is it right here from this support beam up to right here. This is all the block entity behavior. So there's not many of them in the game, which is surprising. But so I didn't have a lot to look at, a lot to reference in terms of how these things work. But essentially, you can save attributes with them, and they're saved with the block entity. So you can't save the properties. You cannot change the properties, because I tried. So the entity behaviors, here's one, the properties. So this, I tried to find a way to change it. You can't change it. It's read-only. You cannot change these depending on whatever. They're static. The only thing that you can change that is saved with the game uniquely to the block is the block entity attributes. But the block entity behavior, which we have, has a from and a to tree attributes, which is called when the block entities attributes are called. So the game, when it's saving the world when it's loading a chunk, or when it's loading the block, or when it's syncing to the client. This is what it uses: the from and the to tree attributes. There's the to. So the to tree attributes is the save. The from tree attributes is the load, right? So when you save, you want to load what you save. And you want to use the same IDs, all that kind of stuff. So because the block entity behavior has all of this ability to save stuff, and it's disconnected from the block entity itself, I thought it was a very good use of a place to save the wire connections. So getting back to this, the wire connections are saved in the behavior, which is an offshoot. So the behavior is pointing here, right? The behavior actually saves the wire connections. Hey Andy, how's it going? I'm trying to break this down. It sounds in depth, but it's way more simple than it sounds. It's because of the different layers of how the game works and its objects. So we have the block. Whatever the block is, it's a wired block. If it has the wire nodes, it has to be a wired block. Now it'll be an inherited version of the wired block. So like when I come back to my test generator, right? That's a block entity. Test generator. See how this is block, right? When I finally implement all of these changes, instead of this being a block, it will be a wired block, right? It'll be a wired block that adds stuff to the block itself. Okay. So we have the block. We have the block entity, which this is where all of the meat and potatoes go with simulation. If it's a machine or if it's a generator, what it does, when it simulates, how often it updates, like consuming power or producing power. The block entity is basically the bulk of the work. The behavior is just it's like the wire that's plugged into the outlet. It's the thing that connects, right? You have the mod system, the catenary mod system, and then you have the block. There's something that has to go in between that. Well, that's the behavior. The behavior is holding the connections. It is the thing that builds the network. So the behavior stores the wire connections. And how I'm doing this is I'm storing the connections that start at that node, and I'm storing a copy of the connections that end at the node, right? So if I go back here, this is going this way, and this is going this way. Okay, so this is an end, this is a start, right? This connection, this wire right here, this is the start node, this is the end node. So if we go up here to the behavior, and again, this is the base class. This behavior is the base class, and it should be inherited in implementations, which I will have one as the electrical system. But I wanted to get all the base. I had to get all the base objects done first. So this is the base behavior class. Wires start, wires end. Wire start is the most important. What wire connections and the placed wire object is a beast that could probably be optimized, but it stores all of the details. The start and end of the very specific wire points, the function, the block ID, the thickness of the wire, the master block positions start and end, which should allow for multi-block systems, right? So multi-blocks will go there. The wire mesh data, right? Mesh data. So when I generate the mesh for the wire connection, the actual 3-dimensional mesh that creates this, I want to save with the system, so I don't have to keep regenerating it to try to save on frame rates. I'm really trying to be cognizant of FPS performance in this mod. And then the start and then end selection index, and the network ID. So I'm just basically dumping all of the data into this, and maybe we can optimize this. Maybe Tyrone can offer some I don't know, some suggestions on how to optimize this. But this here, right? This has the wire connections in it, right? So this connection is like the start. This node right here has the start. This is a node. This is essentially like a relay. This, because of this directionality, this is an end. So if you wanted to represent this in the behavior, if you connected this to this, the end, where is it? Behavior. Wires end, right? Incoming placed wire connections. So it won't have a wire start because there's no connection originating at this spot. There's a connection ending at this spot, but it's still connected. I need to save that callback, because if you broke a connection down here, I would have to be able to rebuild the network. And the only way to do that is if you can bounce the connection, both directions, and you can actually iterate the network and figure out who's connected to what. It's the only way to rebuild the network. The mechanical system operates very much like that. If you break, like if you have this really complex mechanical network in the game and you break a block in the middle, right? It rebuilds that network from both directions. That block that you broke, it rebuilds the network from here, and it rebuilds the network from here. From the origin, the networks are always rebuilt from the direction of the producers, right? Whatever is producing the mechanical power, that's where the game starts to build the network. And so your windmills in the base game will always be the start of whatever network that it has to be rebuilt. And whatever producers exist in the game will all follow that path. So I had to store a way to go both ways in the network. And remember, this is just the wires. This is not the power. Right now, power is not even a part of this mod, right? The power network is not even the there's barely any anything regarding the power network. It really doesn't exist yet. It's just the wires. How do the wires connect to one another? How do you save that data, and how do you render it? That is how I'm doing the behavior. The behavior is saving all of the wire connections, both incoming and outgoing. But when I'm processing them, when I'm rendering them, only the start is what's being processed for every node. Meaning I am not double rendering the nodes. Because as long as I'm always processing the start, there's always going to be an end. So I'm just processing the start. And so the on tessellation, and I had to work with I've been talking back and forth with Tyrone a few times. He actually became a patron, believe it or not. So I've been talking back and forth with him about some of the nitty-gritty details here, and there is a blah, 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 on tessellation. Okay. This word, tessellation or tessellator, this one it's a scary word. But on tessellation is called for every object when a chunk is redrawn, or I should say rebuilt, right? When you mark a chunk dirty in code, this is called for everything inside that chunk on tessellation. It is what builds the 3D stuff in the chunk that is drawn. So when this is called, right, I have to add the wires, because the wires are technically a block. They're technically a block, but they are a very unique type of block that are stored inside of other blocks, inside the behavior of the blocks, right? It's not a block like a dirt block you place down. It's a block that exists in sort of like, it's overlapping into another block. So I have to manually add the mesh into the block. So on tessellation, we have this, which says the placed wire. This is why I save the mesh inside the placed wire object, because this call wiremesh.makeWireMesh is a static call, and it's the one holdout, the one thing I copied from the signals mod, and I tweaked it a bit. But this thing is what builds the mesh for wires going from point A to point B. This is what builds the mesh. It is a amount of code that I would have never figured out on my own. This is not my forte. This is well beyond my brain's capacity. I have no idea where this guy got this code, but I'm sure it's copied from somewhere. It's just like I don't think this was his code. Maybe he tweaked it here and there, but like I just couldn't. Yeah, I just couldn't. Anyway, so this just makes the mesh, and it's a static, which means it doesn't really rely on an instance of the class. You can call it regardless of a variable. Same with the static float catenary. This is a formula of catenary using. It's just, this is what dips the wire going from A to B, right? As you get further away from. Okay, let me try this going this way. As you get further away from this point, it offsets based on the cosine, right? So the cosine wave, obviously, not everybody, but most people know the sine and the cosine waves. So it'll dip that down and then bring it back up based on the cosine wave. That's what this does. Is it takes the distance and then throws it into this formula, and it's what offsets. So you have a straight line, right? Imagine a straight line going between my fingers. Then you pull the line down. That's the cosine. That's essentially what this does. Is it just takes whatever vertices you go across and it pulls them down and it offsets them down a bit. Essentially, that's what that does. Now, if you wanted to do like wind, if you wanted them to like wave in the wind, then you would have to. Oh man, I don't even want to think about that. I'm going to stop that thought right there because, oh Jesus, yeah, no thanks. All right, so I saved the mesh because imagine that formula running, right? If you have dozens of wires in your base, imagine that formula running every time it has to rechunk or redraw the chunk, right? That would be terrible on the performance. And so once the wire is connected, I want to save the mesh and be like, I don't need to regenerate that mesh again because I generated it once. It's done. I don't need to do it again. And bingo bango, what this detects is it grabs the placed wire in the start array, right? All the placed wires. It grabs each one, however many there are, and it says if the mesh data, the wire, right, is the placed wire, that wire mesh data equals null, then regenerate it, right? Regenerate it if it's null, which means it doesn't exist for some reason. once you regenerate it, then you save it. You do a clone, you do a copy, which because if you didn't do this, as soon as it went out of scope, the garbage collector would come in and erase it, and you would lose your mesh. So the mesh data has a copy of it, and then you add the mesh data to the tessellator pool, right? And it adds those vertices to be rendered in the chunk, and you do that for all of the starting wires. So it is the thing that literally adds the physical wire to the chunk to be drawn. Now let's see. I don't know what gives it the texture. Not yet. I haven't gotten that far. But if we look at DNSpy, and DNSpy, this is like a lifesaver of a program, because you can actually search, you can analyze certain things, right? I have a bunch of stuff. You can see what I usually use to analyze. So analyzing, you get like what calls it, what it's used by, what it's overridden by, what uses it. Like there's just tons and tons and tons of stuff that you can use in DNSpy versus just looking at the source code online. DNSpy is just so good. But the support beam here, it does something, the on tessellation, right? The beam mesher here is different than what I did. Generates mesh. They actually pass in the original mesh right here. The original mesh, get or create beam mesh. What this does, I actually have this in my code somewhere. Get or create. Why wasn't it in that list? No, wait, that was... Okay, that's why I'm in the wrong object. This is where I want to be. Get or create wire mesh. So this actually gives me the block. Remember, the block is the wire. If we look at block types wire catenary, I think I already have it loaded. Yeah. So LV power, MV power, HV power, EV power, all power, signal red, signal green, and communication. There's as many wire types as I could think of. And the red and green, I'm basing that off of Factorio. Red and green signal. So you could actually split that up. But I wanted to do it this way because another mod could come in after the fact and add to this array. And add to this to shape by type. And add to attributes. They could literally add another type to this block, and the game would just load it as if I did it. So I wanted to make it mod changeable. So there is some specific attributes, right? I haven't gotten into the code that actually loads any of this yet, but I have max length, thickness, wire function, power tier. Power tier is specific to the power mod that I'm going to be implementing, but signal mod, wire function, you could have a mod that adds things in there and then create your own objects in code that load those specific things. That is easily an option. So I just wanted to make sure that I was covering all the bases and it was as extensible and customizable as possible, because now you can actually mod these values, right? If you wanted to create a mod that rebalanced the length of the wires, the max length, you could come in here and do that. You could create, 255 is the max length, which would essentially be unlimited. But I put arbitrary numbers in here now. I don't know, like 30 blocks. 30 blocks for a wire. That's almost across an entire chunk for one wire. Anyway, we have all of the wire types in here. And so the blocks, the shapes, each one of these shapes, you can see LV power, MV power. That's bare copper. That's bare copper. Then we have a bunch of insulated. Then we have signal red, signal green, and then another insulated. Right? So I have these blocks specified in shapes. Right? Bare copper, insulated, signal red, signal green. Those are the block shapes that have the texture. That's the important thing, is the texture of the block. Now, still trying to work out how the texture gets applied to the thing and the stuff. Tessellate shape. Yeah. Not 100% sure. I have to dig into that. I'm pretty sure if we look at DNSPY again, it is somewhere in generate. Get or create beam mesh. There it is, generate mesh. It's somewhere in here. This is what actually generates the mesh for the block. Right? And there's a bunch of code in here that I don't understand. Again, 3D stuff is not my forte. So all of this stuff, yaw, pitch, like I don't understand what the vast majority of this stuff is trying to do. Like what effect it has while double R length. Like, I don't understand. We have this slump per meter. It's almost like he wanted this to be used for wires. I suppose if I really get desperate, I could implement this exact thing and slump per meter. I could add because there's zero. This is 0 for support beams. There's no support beam that has slump per meter in there. So I could probably add that in, but for some reason he puts in the original mesh, and then he has this clone, and then he takes a transformation and then adds the mesh. I don't understand, because the original mesh is just like, it's just this tiny little cube. I don't know why he does this. Like, he transforms it, and then I don't understand what this code is supposed to do. I don't understand what it's supposed to do. If anybody knows why he takes the original mesh, which is just a simple object in the 3D modeler, right? It's just a single simple object. Why he does this? Does this I don't know. I don't know. I don't know what it's supposed to do. With color maps, with XYZ faces, with render passes. So I'd have to either work with Tyrone or figure it out, or just sort of brute force it. Because I have no idea. I have no idea what this code is supposed to do. How is building double R minus length. So length is square root. So yeah, it's finding the three-dimensional square root of dx times d. Yeah, end of x. So it's this is trigonometry. Why? Again, Like this is code that that I probably could have understood like right out of college when I had my linear algebra class, but it has been 20 years since then. So yeah, I don't remember any of that code. I haven't had to use any of that in a very, very long time, so I can't. Yeah, the more abstract the math, the harder it is for me to visualize it. And I really have to visualize something in order to understand it. Anyway, Matt, what is Matt? Float math. 16 floats. I don't understand, like, it's an array of 16 floats. Identity. Sets a mat forward of them. Identity. Like, I don't know what any of this code does. I don't know what it does. And if I don't know what it does, I don't know if I need it or not. And I don't know how to use it. So, anyway, okay. Let's see. What was I doing? Oh yeah. So this catenary mod is the thing that tessellates the shape. Get cache shape, original message. Get or create wire mesh. And essentially this just pulls in the base shape that I have defined here. Right? So it pulls that shape in and it gives me the mesh. This mesh data. This out, it means it's going to create the mesh data, and when I come back, that's going to be full, and we just said, hey, this is the mesh data. All right, and we save that to a variable, right? So we don't have to recalculate it every time. So you place one wire, it's going to create that when you first load the game. It'll add that to this original wire message. It's just a copy of that. The next time you create a wire, it'll just pull that same exact information out. It's just not gonna have to replicate that work. In other words, that's just another savings in time. All right, so we've covered the behavior, right? So the behavior is saving the wire connections that go out and the wire connections that come in, but we're only rendering the ones that go out. Right? The connections that start at whatever position. So this is when it iterates, this wire right here, right? This wire right here will render when this node is updated. Right? When the tessellator gets around to this node, this wire will update, but not this wire. This wire back here will update or will be added when whatever node is connected to over here gets, updated. When that call gets run. So that is essentially where I'm at now. If you remove this, I'm having a little trouble figuring out how to differentiate these connections. Because imagine this connection here. This is a relay. So imagine copy. Okay. Imagine that. And then this. Whoops. Oh my God, stop doing that. Okay. Now, this is where my mind starts. I start to like my whole brain starts to fizzle. Imagine this is a situation. Now this node, and if we have this connecting right here, this connecting right here, but then you connected it this way, right? You're connecting. You're holding the wire in your hand and you're connecting from the pole to this, pole to this, hold of this, then you take this machine up to the pole. It's the same connection. The wire is added, right? But now it's going the other direction than all these other ones. How do you differentiate which wire? Let's say you want to remove one of these. Whatever one. Just imagine you want to remove one of these. How do you remove a single connection when there's an array of 3 outgoing and 2 incoming? How do you differentiate those? So, essentially, what I have a call in is it the wired block or the behavior? I don't know if it's the behavior. Let's get drops. There it is. Get wire collision boxes. Okay. Because, again, all of the wiring system is all generic. The wiring system does not care what network is associated with. It just doesn't care. A wire is a wire, regardless of what network is associated with it. So, again, I need to be generic, but I need to be accurate. So when you remove a wire, I need to really make sure that wire gets removed. Now, there's one restriction. Between 2 points, I didn't. Okay. Between 2 points, there can only, between 2 individual points, there can be only one connection, regardless of direction. Right? So if this wire is connected this direction, right? Let's call this like A and B. So from A to B, this has the start, right? If we go to the top of my behavior here, wires start, wires end. This, in the wires start array, will have this connection. The placed wire object. This will have it in the wires end. It's the same connection, but it's copied in 2 different places. Wires start, wires end. Now, if you then have your wire, right? Let's change the color. If you then click on this and you try to stretch it going this way, right? It will error out and say, "Nope, I need it to error out." And say that wire connection is not possible. Right? That is not possible. So in the placed wire object, right? This is when you have a wire like this, I have a function in here for equals. So this, I actually override when you're saying, is this equal to this? Is this placed wire equal to this placed wire? I need for equality to exist, that equals, right, needs to go both ways. So this is the code right here, equals, because I override the operators here, and all it does is call the equals. Left equals right. So this equal says the start match means the starts are equal. So this start, remember, this is right and left. This start equals this start. This end equals this end. I know I'm doing it backwards, but because the camera is switching me. So the starts and the ends are equal. That's an obvious equality. If the starts and the ends are equal, then obviously they're equal. But also, if the mismatch, right, means the starts and the end are equal, right? This start equals this end equals that start. Means right here. If I try to connect this one over to here, means this start equals this one's end, and this one's end equals this one's start. That is equal. I do not want to allow that connection because that would create like an infinite loop. If you're iterating through nodes in a network to rebuild a network or to verify a network, and you run into this, you're just going to be going back and forth. You're going to create this infinite loop because this start node goes to this end node. Well, then you want to go, then once you jump that, you want to process all the start nodes there. And then you want to bounce, do all the start nodes there. So if you go to this node and one of the start nodes goes back, right? Well, then this one is going to have a start node going forward. That creates an infinite loop. And those are bad. Those are really bad because they're infinite. You get in this infinite loop, and the system, you would eventually crash the computer because it's an infinite loop. You're taking a whole lot of memory. Every time you make that jump, you're adding more and more calls. So it's not a good thing. So I want to make sure those are equal to prevent people from having double backs, because there's no function in the catenary mod where a single node, right? This is a wire anchor. This is a wire node, has more than one function. So this node only has, let's say, LV power. That's it. You cannot connect anything else other than an LV power to this node. You can't add communication or signal. Those are other distinct nodes. So there's no reason to add a second connection between these two, which is why I have this. So the start match, if this is true, or this is true, but it has to be an exclusive OR, right? It has to be an exclusive OR. Because this one will, if this is true, this will never be true. If this is true, this will never be true, right? It's physically impossible for both of these to be true. That is why I have this. Because if I just used an OR, right? If I just used an OR, then it would have, let's see, C# XOR. Okay. Boolean logical operators, right? So this right here, this is the main thing I looked at. This would never exist, right? This would never exist. But these two could, as well as this one. Exclusive OR. Now, if you looked at the OR, I think if you looked at the OR, I forgot what it, where was it? That's exclusive OR, logical OR. Why isn't there a nice, really hate when people do examples and they don't stick to the same damn format. This is really easy. This is really easy to understand. Why does this not exist for this? We need all of this shit? What is up with that? Like, give me this with just the OR symbol. That's all it, like, why reinvent the wheel? Like, what is the second like, what? Okay. So, OR, right here, right? This is X or Y, but I wanted to Yeah, I wanted to do so when so this would never be null. I'm not. I don't care about null. False true is true. Maybe I could have. Maybe there was something. There was some reason that I didn't use or. That there was some reason that I needed to use the exclusive or. I don't know what it was at this point. I honestly don't. But anyway, if this was true or this was true, I needed to return true. Right? If these were both false, I needed to return false. And I want to say that's why I did it that way. But neither, if this is true and this is true, then something really bad happened, because that should never be. This start and this end should never be equal. Right? Other position. So I use an exclusive or. To this point, I can't remember why I did it that way. It must have been like 11 o'clock at night and my brain must have been frazzled or something, but whatever. Logically, it still works. So I've covered the wired block, which is basically the thing that has this, right? The wire node. That's the wired block. Then I covered the behavior, the entity behavior, which covers the connections. Right now, there's some other things, because this BE behavior electric connector is not this. This is the base object, right? The BE behavior electric connector is this one, which I haven't touched in weeks. So this is still this right here, block entity behavior. This will actually be block entity behavior wire right here when I get everything finalized. But this, the block entity behavior, will store all of this and then add all of its connections and its network IDs. So you can see the iWire network I can probably remove off of here, because it's already part. So I can do block entity behavior here and here. Right? The purpose of me trying to separate the catenary mod, this section here, the catenary, the reason I'm trying to make this really extensible is I want, and Tyrone has already told me that if it's good and it works and it's like decent, he will integrate this into the base game. Right? So he's got the support beams, he's got a ton of stuff in the base game. There's even stuff in the base game that you can't even access in survival mode. But I'm trying to create a framework for other people to use. And part of that is going to be my electrical system, right? So, yeah, the electrical system I want to also integrate. So the base game has an electrical system, and the whole thing is customizable. The whole thing is overridable. The whole thing is changeable. You can implement your own electrical system. You can use mine. If it's integrated in the base game, I want a lot of people options to use it, and I want to be very obvious with the objects that implement this. Very, very obvious. So the block entity behavior electrical connector, that is that. And so when I get down to it, right now, there's not a lot. Actually, I can get rid of all of these. But there's a bunch of stuff that I can override in the block behavior wire, right? There's a bunch of stuff that I can override in here. And then that will be the basis of my actual wire system, which I need to implement still, or the electrical system. That would allow me to actually run wires back and forth because I don't have any nodes, relays. Right now, the test generator and test machine, I haven't loaded up this mod. I haven't compiled it in quite some time. There's still a lot of code that I have to put in here to make sure our states and stuff are good. Because there's some code in here that I want to do shape by type and change the shapes based on the state, where the state of on has its own animation. Because if you look at vintage engineering, if you look at like machine static translocator. All right, so varying group state, normal, broken, unrepairable. The normal state has an animation. When it's in that state, the animation just plays. So how do they do that? Well, one thing they do is entity class by type, entity behaviors by type. When it's normal, it's animatable. Right? That's a behavior. Entity behavior, animatable, when it's in the normal state, regardless of normal state, whatever side it's on. So normal dash star, star dash normal dash star means static translocator dash normal dash star. So normal, whatever orientation is, northeast, south, or west, that's this star here. Normal dash star, that's the direction that it's going. So if it's normal, it's animatable. We should see, yes, right here, state. So if I looked in this directory, I would see 3 different shape files for this object. I would see in this directory, static translocator dash state means there would be a normal, a broken, and an unrepairable shape file. That's what they would be named, physically named. Normal, broken, and unrepairable. And if I looked at the normal, it would have an animation. It would physically have an animation in the game. So what I'm thinking for my objects, my machines, right, is having a separate shape with the animation for the on. Because you can swap the shape file, you can swap the block without causing major game updates. So when you place a block, the block creates a block entity, right? If you swap the block, if you change the block, you would destroy or recreate the block entity. But the game has a unique function called exchange block. An exchange block will swap the block. Remember, the block is separate from the block entity. Will swap the block and not cause an update or not cause a change in the block entity. The block entity will remain the same. It will function the same. It will not be destroyed and recreated. So all of your data will be intact. It's just the shape of the block. It'll just change the shape. And if that shape happens to have an animation, it will play the animation. And so what I'm thinking is having 3 different shapes, or even 2. The sleeping could use the same as the off. Or I just wanted to have a separate one in there. But basically the on and the off, the on version will have an animation and the off version won't. Sort of like Factorio. The sprites in Factorio, like the assemblers, it doesn't matter what is being made, the animation is the same. And so I'm thinking the same is true, and the same is true is also satisfactory. So whatever animation somebody comes up with, and I'm not saying I would do it because I'm not skilled in 3D modeling, animating textures, stuff like that. That's why my test machines look like presents, because I just made them simple. But this would allow somebody to create a machine that has a cool animation that would be swapped to the block when it's operating, and have that animation play. As soon as it's done operating, it's done and goes to the off state, then the animation would stop. So there's a bit of code that has to be done, but the example code is pretty easy to find. I could just find the static translocator in here, the block entity, or the block itself. I'm sure there's the block. That's the code that would swap it to the normal once it's repaired. So the block would likely have the code of interaction. If you right click it with a gear, right, you're repairing it, which would swap it to the normal. And there's a call to the exchange block, and that's what you could look at as an example of how to do that. But all of my test stuff will have, that will all be very much done in here for my test machines and stuff. But at any rate, so the electrical stuff is not done yet. So the Catenary mod itself, the on interact is what I've been working on the last couple of days. So it's somewhere in here. Trigger, nope. The on interact is the meat and potatoes. There it is. No, that's on render frame. There it is. On interact. Okay. This is called, if I look at the block of wire, right? The block that is the wire. This is the Catenary block. This is the block that I showed that has all those different variants right here. Block wire is the class. These are all the variants. So depending on what variant you're holding, right, the code will be Catenary-LV power. That's the block, the stack of blocks that you're holding. So this is the block of wire. If you're holding this, on held interact start. Interact is the right click. Attack is the left click. So interact, I pass this interact to the mod, the Catenary mod. So I don't handle the event locally. I pass it to the mod. The same with attack. I pass it to the mod's cancel place. So when let's say you right click a node and you're stretching the wire and then you left click, that will cancel the placement, right? It's a way to cancel it. So if you cancel it, then you return out of it and you don't lose anything. But if you right click on interact, you pass this to on interact. And this is what I've been working on lately. Is really, did I close the Catenary mod? Nope, there it is. So this is getting the details, right, of any person in the game. This is run when somebody clicks on it. And so the workspace is sort of a temporary holding of again, I'm pulling this from the beam placer. I'm sort of replicating a lot of that functionality. And this is how the beam placer does. Is the workspace holds some of the temporary items, some of the in progress for each user, right? So this get workspace by entity, there's an array in this object called workspace by player, which holds the string. This is their user ID, their unique ID, and then the workspace they have. It's just a dictionary. And so that just grabs the workspace and shows me if it's if they're actually in progress, right? And so there's a lot of double checks. The try access, this detects claims, and if you have permission, I wanted to make sure people had permission to change the chunk to build. So the flags of build or break, you need to be able to build to be able to run wires. So if you don't have access, bomb out of it. Don't even do anything. Now, if they're not building, now building means they're already in progress, which means this was their first click on a node. All right. So logically, I have to go through this and go, all right, we have, what is the current mesh? Grab that. Gets the default mesh for the wire. Because remember, they're not in progress yet. And I've already grabbed the wired block and the behavior. Now, if either of these are null, which that means, and I use the iWire anchor here. This is part of like the polymorphism. Instead of being my wired block, this will allow people to create their own base block that implements this interface. So if somebody has a really custom use for the iWired block or iWire anchor, this would allow them to implement that. But they have to implement iWire anchor. So I grab these blocks. If either of these are null, means none of these means the line was not successful. So if the behavior wire, again, this is the base object. The base object. If you inherit from this base object, this will still be valid because the base object exists. So the behavior will still grab that behavior, even if it's a descendant, even if it's a class that derives from this class, it will still, polymorphism still is successful, which is this is what's great about programming. I don't have to be specific. I can be generic with my base class. So if either of these are null, that's bad. We're not even looking at a block that has a wire connection point. Nor are we looking at a node, right? We're not even looking at a node that has behavior for wire connection points. So if either of that is true, bounce. Get out of here. Don't even try to connect the wire because it's not possible. Now, if those both exist, that means, hey, we have a valid block and we're good to go. We are looking at a wire connectable block. Now, let's see if we can attach wire. And the selection box index, this is one of the most important items in the mod. Which selection box are you looking at in the block space? Because close your eyes and imagine a block. When you look at a block, you see a very faint black highlight around the block. Now imagine looking at a kern, the kern. There's kern. There's a selection box on the bottom, and there's a second one on the top. There's two in the same block space, which means there's a selection index of 0 or 1. So the selection index tells you what you're actually selecting. So the selection box index, the way that these are run, when you look at a block, a wired block, this is why having base classes is so important. When you're looking at a wired block, there's a game call automatically that you can override called get selection boxes. It's in here somewhere. It's in here somewhere. Get wire selection boxes. Get selection boxes. This one is special. This one is not called automatically. This one is. This is an override of the base class, overloaded, for the addition of wire anchor selection areas. So this, normally, if you have a normal block and you have one item of collision and selection boxes, we look at the static translocator here. Collision box, selection box. So when you look at the block, this is and can be separate from the collision box. So you can see the collision box here. The Y value is tiny, which means the collision is like right on the floor. It's exactly 0.125 of a block up off the floor. So the collision box, you can literally walk over the top of it. But the selection box is the entire block space. Right? A single block. That's what you select. So when this comes in here and gets selection boxes, it's looking, God, I keep clicking on that for some reason. It's looking at this. It's passing this in when you look at it. What I do is I override that call. And I say, hey, when you call selection boxes, what I want to do is I want to add these. This is a selection box. I add all of the wire node selection boxes first, and then I add the other one, right? So it adds all of the wire. If there's just one, it'll just add one. If there's 5, it'll add all 5, and then it'll add the base block. The other one here, get wire selection boxes, is basically the same thing, only it doesn't include the base block. It doesn't include the base object, which is the base right here. So the get selection boxes here is all it does is it verifies I'm holding a wrench, which is kind of funny. And it's only done on the client because the server doesn't care about the selection boxes. Player is holding a wrench. I don't know why. Why do I do this? This is wrong. Okay. Because they could be looking at this and they could be holding the wire, and that's what I want. So this is wrong. Player's holding a wrench. So yeah, this would not work. Get block entity. Block entity, I get behavior. So this is getting the behavior. Okay, yep, this is wrong. Wired block. Get selection boxes. Okay, so why do I do this? Okay, wait a second. Let me look at this. Let's look at this flow for a second. I have two different, this is doing two different functions. I remember why I added this code, because I added a wire tool behavior wire tool. I didn't want to call it a wire cutter just because I'm sure there's 50 other mods that also probably add wire cutters, and I didn't want to get too crazy with it. But essentially this is a behavior, but it's not a block entity behavior, it's a collectible behavior which you can add to like handheld items. The block entity behavior is a very, very specific thing. Collectible behavior, literally you can add to both blocks and items, and this one you can add to any tool. But one of the tool types that I had him add is a wrench, and I had him add a bunch of other ones too, but wrench is a type of tool that he added. So I didn't want to make it specific to my tool, but I wanted to include a tool, of course, just like every other Minecraft mod does. But I wanted to make it generically acceptable to any wrench, which is why I have the wrench here. And again, this is, all these question marks mean is if this is null, don't crash, right? Just stop, and it'll be false. Like, if any of these are null, this will be false, and it won't even go in there. It has to get all the way to the end, and it has to be equal before I actually like go into here. So if they're holding a wrench, come in here. Which means if I'm not holding a wrench, it will never get in here, and it will come out here, and it will add. This is why I was confused at first. This adds the wire anchors here. The rotate, right? The rotate is because these are rotated. The local variable here, the wire anchor, is derived from the rotated cube. If we look at the wire anchor and we go all the way to the bottom, wire anchor, a generic object to represent a JSON-defined wire anchor, rotatable with rotated copy, is not related to iWire anchor. Yeah, this was kind of a confusing thing, but this is exactly what it is. So I didn't want to. I could probably call this like wire node, since that's what it's called in here. I guess I could have done that, but I already have a wire node in here for other reasons, which are, too numerous. I have a ton of stuff in here. Anyway, so the wire anchor has the index, the wire function, the net max connections, and the network ID. Now, unfortunately, I have to eliminate the network ID because I realized that I couldn't add it. So this is, the wire node is literally this object. Network ID is not a part of it anymore. I ran into, problem. So this, I included a way to pass them all in, and then I included a way to just pass a JSON object in. Okay, so this is a lot easier for me to do than this one. This is just a massive amount of just nasty things. So here is my wire anchor right in here, and when I initialize my wired block, I grab all those anchors somewhere in here, unloaded. There it is. So when this thing is loaded, it will automatically add all of the nodes, right? It'll add all the nodes into the array. And remember, this block is used for every block you place of this type. Every single block has this type, and all of the attributes are the same for the block, not the entity, the block. So every instance of the block It uses the same values. Okay, so that means this right here will add all of the wire anchors if we're not holding a wrench, right? So it'll add all the wire anchors, and the last thing it adds is the selection boxes from the base class, which is these. The collision selection boxes, yeah. So the base class, this is added last. So the indexes, if we want to index into that selection box, indexes starting at 0 up to the number of them is the wire nodes. Anything after that is the block itself, right? So the block itself is technically a collision box, but it's not a wire node. It's not a valid node. If we're holding a wrench, things are different. If I'm holding a wrench, that means the functionality I want to change. This is when I hearken back to, how do I remove a wire that's been placed already? Well, I need a way to have collision boxes with these wires in order to differentiate them. So each should be going a different direction, right? Because between 2 points, you'll never have more than one wire. Even if blocks are very, very close together, the collision boxes may overlap a little bit, but you should get separate collision boxes for every separate wire, regardless of how close they are. It depends on how people lay out their factories, but this should be distinguished actual cubes. Now, I can't, unfortunately, create a collision box for the entire length of the wire, because the max size of a collision box is one single block, right? So it's really, this is another thing I talked with Tyrone with, is the game is not set up for collision or selection boxes to be larger than a single block, unfortunately. I wish they could. That would be so nice. So that we have to cheese it somehow. So what I do is I get, if we're holding a wrench, I get the entity, whatever it is. Block entity is just a generic, get the entity, and then get the behavior of the wire, right? Remember, this is what stores all of our wire connections for that location. Every block position is going to have its own block entity and its own behavior set with its own unique attributes, storing all of these wire connections, incoming and outgoing. So, if I grab, again, all the null checks are just sanity checks to make sure, because if we crash or something happens, I do not want some catastrophic failure here. So we need to get the behavior, right? So block entity question mark means this could be null. If this is null, this says, if this is null, then this is null. If this is null, we don't want to do anything. But if it's not null, we come in here and say, hey, if the wire start array has has stuff in it, or the end array has stuff in it. If either one of those arrays has wire connections, right? If they have wire connections, then get the wire collision boxes from the behavior. So the behavior, it jumps into the behavior then, and I have a command in here, get wire collision boxes, literally iterates through. I don't know why do I do all of this stuff here? Active hotbar slot, no. Collectible block, no. I don't need to do, what is all of this? No. This isn't an override. Yeah, I think we need to return array of placed wire collision box at this location used for removing the wire. See, this is why I like putting comments everywhere, because it helps me. Yeah, I think this whole thing can go. If wire start equals null, and damn it, and wires end equals null, return null. Okay, collision boxes is just a local variable, boink, right there. Because if I generate these, if you're holding a thing and looking at the block, and these are generated, I want to save them so I don't have to regenerate them every time. This again was derived from the support beams, so I'm having to figure stuff out. I can pull up the support beam version of this and really confuse everybody. The support beam placer, get collision boxes. So this is kind of where anyway, this is where all of this goes. Beams, collision boxes. So here is the code, right? That gives you the collision boxes of the beams. And the collision boxes are these little squares at the base, at the start and the end, right? So when you're looking at it, they actually appear on both sides. You don't usually see them both if they're off screen, but they both appear there. But I didn't need that. Plus, there's a bunch of math in here that gets really confusing. Because it's adding 2 collision boxes for every beam, right? 2 collision boxes for every beam means you need twice the length of the array, and then you need to do some shenanigan math with actually adding them in there, because you're adding a start and an end to each beam that's in place, and there could be 20 beams all sprouting from one single block, right? You can have a bunch of them coming off of there. So this wasn't exactly what I wanted to do, but I come close. So rather than worry about all the weird math, what I do is I say, I only want 1 box per wire, whether it's incoming or outgoing. Doesn't matter. If I'm looking, imagine you're looking at a power pole. You're looking at a node where all these wires are connecting at a power pole. I don't need a collision box on the other side of the wire, way down the line. If that's 20 blocks away, I don't need that collision box. I just need the ones that I'm looking at. And I need them a little bit bigger, so I increase the size a bit. So this is a quarter of a block. Think of a block space. This is a quarter of the block space. And essentially, I create a list rather than an array. I don't know. I don't know why it was implemented the way it was. I don't know why. But essentially, I iterate through all of the starting wires that start at that location. Remember, I'm looking at a very specific block location. This behavior is associated with a specific position. So I iterate through all the starting wires, and I add a collision box. And it's very simple, just a cube of whatever size, right? It is essentially twice that size, because you're minusing a size and you're adding a size. So in the end, you're twice the size of size. So I add, for every wire start, I add a cuboid. A cuboid is just a cube, right? And then I iterate through all the wires that end here as well. So all the outgoing wires get their own square, and all the incoming wires get their own square, which means if I'm looking at a node, if I'm looking at a wired block, I get all of those connections with this call, and it's yeah, I get the collision boxes. Once I have this generated, I store this away. Because once they're generated, I don't need to redo them. Unless I add or remove a connection, then I have to reset it. But then I return the collision boxes. So coming back here, this returns, if I'm holding a wrench, all that it returns is the collision boxes for the wire. It ignores the nodes, it ignores the block. All that is returned are the wire's collision boxes. All right, I need to take a quick break. I had 6 cups of coffee. I will be right back. All right. So I think that covers that. And then we have, because of this, the collision boxes should have a 1-to-1 relationship with the wires that we have at the location. So let's look at the behavior wire tool really quick and say, how are we going to block selection? Again, I have to sort of get into the debugging mode when I finally have something that compiles, that all the game files work, everything gets loaded. It's gonna take me another week or two. Once I finally have all of this foundational stuff done to actually get the electrical system, enough of that going to be able to test some of this stuff. because I don't have any electrical network stuff done yet. It's not even started. But once I have the foundational stuff going, it should be relatively straightforward on how to build and rebuild. The really tough part, like building an electrical network, fairly straightforward. The tough part is when you remove a connection in the middle of a network, how do you rebuild that network? That is, that's going to be a lot of code, and I really am worried that it's going to be brutal. Because I don't know how to like multi-thread that. I don't know how to spin that off and be like, you know, this has to rebuild a network. How do you do that efficiently? And the only code in the game that I can use as a template is the mechanical system. And that is going to be rough because, believe it or not, the mechanical network is not saved to disk at all. There is nothing that's saved to disk regarding the mechanical network. So if you leave your base, let's say you have a windmill and you have this big mechanical system and you leave your base and it all unloads, right? When you come back, it rebuilds that whole network from scratch. And it always rebuilds it from the power producers. Mechanical power producers. So whether or not I save that, I don't know. I'm tempted to not because I don't know. I'm open to ideas. But anyway, on Held Interact start, what we do here, because we are looking at the block, right? So if we're holding a wrench or we're holding the wire tool, which is essentially a wrench, I copied, I know this is just bad form, but in order to actually get something in that I could test with, that I don't want to mess with too much. Essentially, God. Essentially I just copied the tongs. The mod, there's a mod for tongs, for metal tongs. And so it's got, you know, a tool head, which is the arms. It's got a shape. That's the wire metal tool. So I copied the tongs. I just wanted something in there. If I look at assets, wire tool, wire metal tool, this is, yeah, it's just the tongs. I limited it to more or fewer types of metal, so iron, meteoric iron, and steel, whereas the metal tongs can have a bunch of other metals. I wanted it to limit, and now it's a wire tool instead of metal tongs or whatever the code was. But yeah, I wanted something fast, so we have this. And then did I even add the behavior? I don't even think I added the behavior yet. No, I did not add the behavior yet. Anyway, so the behavior wire tool, when you interact with this, if you're holding it in your hand and you look at a block, anytime you look at a block, anytime, it calls the get collision boxes or get selection boxes. This is called anytime you look at a block. So I don't have to determine whether or not I'm looking at a block. It's just automatically called. If I'm not holding a wrench, then it calls this. If I am holding a wrench, this runs. And it only runs on the client. This would probably only run on the client too. I'm not sure. But the selection box, when you run it, and this block selection, right? So when you're looking at a block, the block selection is an object. So we can look at that object. Where would that be? Would that be under... That's probably under the API. So we can search for block selection. This is why I love dnSpy. Block selection is in the API, I believe. Yeah, API common. So this isn't a survival mod side. This is just the base API. So block selection is derived... Yeah, that's right. Block selection is not a derived class, so it's its own thing. So it has the block that you're looking at, the block actually being looked at, the face that you're looking at, this block facing, right? That's the face, northeast, southwest, up, down. The exact coordinate, right? Relative to the block position. The exact coordinate. The position is a block position object, which is they're integer numbers, so they're not fractions. Right? Fractions are the like hit position or whatever. The selection box index. Which selection box was aimed at? The index corresponds to the array returned by block.getSelection block boxes. So if I'm looking at the block with the wrench, which is this behavior, right? That means I'm only looking at the selection boxes of the wires, which means this block selection dot selection box index should be that wire. Period. Whatever index was in that was in that spot, the selection box index is the wire. So if that connection had 5 different wires coming out of it, your index will be from 0 to 4. The indexes in C# are always 0 based. So what we do then is remove connection. We use the catenary mod, and when we interact, which means we right click. So you're holding the tool in your hand, you're looking at a selection box, and you right click. That's where this is fired. So we have the selection index, we have the entity that you're doing it, the position. No, that's POS. That's the placed wire. Right? So get wire connection in block is the anchor. I might have to rethink this. I might have to rethink this. Get wire connection in block. Position. Okay. Yeah, this should work. I need to look at this code. Go to definition. So this is generic iWire anchor, right? This is generic. I need to go to wired block. Get wire connection in block. Let's see what this looks like. This is the one I was working on. This is where I ended last night at like 12 o'clock at night. So this is being passed in the selection index. If we look at not block wire, behavior wire tool. This is passing in the selection box index into the iWire anchor, right? The iWire anchor is just the generic way, because I know when you have an interface, the reason you use interfaces is you know exactly what is in that object when you use an interface. Meaning it doesn't matter what other things they have. You know if it implements that interface that it is going to work, because this get wire connection in block is part of the interface. So I know, regardless of what the object is, if it implements that interface, it's going to have this call. So I pass in the selection box, and I want to get out the placed wire object inside of the block. Not the behavior. This is the block, because everything is derived from the position of that block. So if we jump then to the anchor, which is the wired block, returns placed wire corresponding to the given selection index, right? So we have in here, we grab the block entity, right? World get block entity, block selection dot position. So block selection dot position is the location in the world that block exists. That position, grab the entity, and then get the behavior. And this can be simplified to this, this is where the question mark comes in. This is why this is one of the newer features in C#, and it's glorious. It makes it, once you know what the question mark does, it's basically a null check. It's great. So then there's a sanity check. If it's null, bomb out. Don't do it. So then I have to have another null check on the other side of this to make sure whatever this returns isn't null. Because then it's just null propagating on null, and it's just have major problems. So now, once I'm in this code here, once I'm here, I have passed all of these tests. Now I need to see, now I have access to the behavior, which again has all of the wires stored. So what we can do, if beh dot wires start dot length is, well, how about we do this? Selection index is greater than selection box dot length. So what does this do? God, stop giving me suggestions. Sometimes it gives you way too many suggestions. A lot of times it gives you perfect suggestions. It's great. It's a little AI action. Okay, so here. Okay, so how I do these logic things in my head is I imagine scenarios. Let's say there's two outgoing connections and there's 3 incoming connections. The index we get is 2, which actually means the third wire connection. So if we have 2 incoming, means it's 0 and 1. If the selection index is 2, which means it is actually equal to that. That's how I figure that out. If it's greater than or equal to this, then we need to return wires end index. Okay. Otherwise, return wire start that selection index. Okay. You see how it just automatically knew what the hell I wanted to do there? Isn't that crazy? This is exactly what it is. So if the selection index is greater than or equal to the number of connections in the wires start array, now this is a problem. This could be null, right? This could be null. There could be no starting index. If this is null, I need to think about this. This is one of the reasons I don't code in real time, like on stream, because a lot of my programming, like, time is just me sitting staring at the code. Just like staring at it, going, all right, let's think about this for a second. if selection index is greater than or equal to the start, then we need to return the end. If BEH dot wires start equals null, or okay, so let's think about this for a second. If wire start equals null, which means we don't have any, if this is true, it won't even test this. It won't even test it. Right? If this is true, it's already true. It'll come in here. If this is false, then it'll test this. So this means that this, I don't technically need this question mark anymore, but I'm going to leave it in there for funsies. So now I want to return BEH.wires end of selection index, and I need to subtract Is that right? Okay, let me logically think about this. Wire start dot length is 2, which means 0 and 1. So selection index, let's say selection index is 3. Or it's 2. If we're looking at the first end node, so 0 and 1 means those are the first two starts, right? Starts are first. And then the end comes in, which would be index of 2, but it would be the third item, which would mean selection index is 2, minus 2 is 0, which is wires in. That's good. Yep, this works. Okay, so this code is operational. This will return the wire connection based on the selection index. And it doesn't matter how many connections are in the block, this will always return the right one. Right? Because you have to sync up your collision boxes with your selection boxes. You have to sync your selection boxes, and we always add the starts first, and then we add the ends. So, yeah, this should work.
Got a comment in chat.
Wire start may be null inside if block. Is that an old inside if block? If wire start. Oh, yeah, you're right. Should that be not equal null? No. If wire start. Okay, my brain. Okay. Good catch. Yeah, you're right. You're absolutely right. This would be bad. Okay, so the scenario is if we have no starting nodes and we have 2 incoming nodes, which would be like if we looked at this, right? If we had a I didn't want that. I wanted that. We had this. Then we had a blue. We had a wire going off this way. And a wire going. Oh my god. wire going off this way. Right? And then because you gotta plan for people to be wiring things in whatever direction they want, right? You cannot force them to wire a certain directionality. So having two end nodes means this is wired this direction and this one is wired this direction, right? Imagine there's the power pole and you're running your wires and you run it into this one. And then you walk way over on the side and you run the wires and connect it this way. So this node is technically two end nodes, but it's still a cohesive network, right? Even though it's two ends, it's still one network, which is why I'm also storing the end nodes, because I realized that I had to create a copy of it. So this situation here is technically having two end nodes, even though it's wired, correctly. So wires start would be null. And the selection index would be like 0 or 1. Because you're looking at two end nodes, it would be 0 or 1. What we do here wire start equals null. I want to try to do this as elegantly as possible without a bunch of code fluff, but I don't know if there's a really easy way to do this. How about we do something selection index minus equals beh.wire start equals null question mark 0. See how it just knew exactly what I wanted to do there? Okay. Selection index minus equals beh.wire start equals null. So if wire start equals null, if this is true, this question mark here is a conditional. If this statement is true, minus equals 0. If this is true, it will minus 0. If this is false, then I minus the length. I subtract the amount started of selection index. And it's just an integer. It's not a big deal. I just subtract how many starts in there. So this is the null check. So it takes care of this. It takes care of this statement here. And I just subtract from the selection index the amount in the start to give me the end. Because if the selection index is greater than start.length, greater than or equal to, then I still want to subtract them. But if it's null, then I just subtract 0 because it's the 0-based array is just in the wire's end. This should work. So this statement is like selection box index equals or just minus or doing an if statement. If bh.wire start equals null, And then inside that block, you go selection index or not equals null. Then you selection index minus length. It's just the inline. It just creates it all in one line. The question mark is a inline conditional. This question mark is different from this question mark here. I know it's confusing, but once you've been programming for a while, it's pretty nice. I love C#. I've been using C# for 20 years. Okay, so thank you for that catch. That would have been a bad thing. Okay, so now we are returning back the wire connection that corresponds with that selection index. So this POS, this placed wire, I should have picked a better name for this. Wire. There we go. Now it's not a POS. Placed wire equals anchor, which is the iWire anchor, question mark, get wire connection to block. So now we know this will return the placed wire. That could be null. If it is null, return, because it's I don't want to do anything else. Because it's not, this is nullable, right? If BH equals null, return null. So having a return null here means I need another null check. All right. So if API.SADA equals API.server, this will only be called on the server. Client, again, the client is a dummy thing. If you're right-clicking, the server is also being fired. The event on the server is also being fired. And only run this on the server because that's all that matters. The server pushes information to the client. The client, any interaction the client has needs to be communicated with the server. So the client is constantly being updated by the server. So cm.remove connection, if you needed a server, and I think there's a chunk. There's a way to grab the chunk and mark it dirty. I'd have to look at the code. I don't think. Well, let's look at. Block behavior support beam. Add beam. So this is adding a beam. This is not. This is not marking the chunk dirty when it does. I don't know what the onTransformed does. I really don't. I really wish he had a bit more code in here, but if you look, it is iRotatable. Implement this interface if schematics containing this block entity need to modify its tree attribute data. I don't understand what that means. This method is called without the block entity existing in the world, yet the modified tree will then be used to actually create the block. I have no idea what that means. Block entity needs to modify its tree attribute data. And the only thing in the interface is iRotatable. If flip axis is null, it means that it was not flipped, only horizontally rotated. I don't understand what any of this stuff has to do with the support beams. I understand the material exchangeable. When the beam is in place, you can right click it with another type of wood and it will swap the type of wood in the beam. Right? And so that is essentially the exchange. You have to override it so there's an exchange width, right? So from block and to block. For each place, beam and beam, change the block ID, all of that. The block ID for me is like how it's rendered. This switches the texture. There's the block entity that marked dirty, so that is something. This dot block entity that marked dirty. So this dot block. That's the wire tool. No, we don't want to do that in the wire tool. We want to do that. Entity block selection. Okay. Remove connection. So we go to the CM is the catenary mod. Dot remove connection. We go here. Where is it? There it is. Remove connection. This is what I worked. This is what I worked on a lot of this yesterday. So there's the placed wire, all that. Get what drops. So the first thing I do is grab what drops will be generated based on the length. This is again ceiling dot distance to. This is however long the wire is. You know, give me some round numbers, which is this math dot ceiling stuff like that. The stack size, right? If the wire is 8 long, give me 8 wires back. That's essentially what it is. And on the cost side of things, there's going to be a similar call to make sure you have enough wires in your inventory. So this just gets the drops, of the wire that is being removed. I grab both the start and the end nodes from the placed wire, because remember, the end has a copy. The start and the end have a copy of the wire. So I need to remove, when I remove a wire, I need to remove it from both nodes. So it severs that connection. So BH start and BH end, I need to grab both of those behaviors. If either of them are null, return, because something happened. A lot of these, as I step through and debug, I'll probably find places that I can put like errors, so to log errors. But I don't want to do it yet because it would just spam the log file. So if either of those are null, get out of there because something went wrong. Neither of those had the behavior, which they should. A wire should not be able to connect to a block unless it has the behavior. All right, so the way that I remove them, I was trying to figure out a way to remove them from the array. Right? The wires start array. Because I have to iterate through them to find which one they take out. But now, now because the selection boxes won't match up. I can't use the selection box index in this instance because I'm pulling it from two different nodes. I'm pulling the start node and the end node. And so it's going to be way different selection box indexes on either side of that. So I can't use the block selection. But I have to use the placed wire, which is why when I have the conditional, the equals, the equal, that's why it looks at both sides. Because I go to the start node and I look for that connection. And it should find it. It should find the start equals a start, end equals end. That should find it. Then I look at the end node where the end the end node is it. Oh, what words am I looking for? The placed wire has the end position. Let's look at the placed object, placed wire. Master end, right? It has the block position. So I grab that behavior. Master end dot get behavior. So the single placed wire, remember, gets a copy. The endpoint gets a copy of it. So it's exactly the same object. It's just the object is in the end array. Am I doing this right? I'm thinking about this. So the wires, the where the master start is, that block in the wires start array will have a list where the start is the same as this placed wire. The start and the start and the end will match. Okay, I'm just going through my head now. Now the end of the array, the node that it ends at will have a copy where the start and the end are the same thing, but the end position equals the end will equal the block position. My brain is having trouble visualizing this. Okay. So the wire start is fairly simple. Remove at I when you find a match. And then reset the wire start array with the new array that has that one removed. So it'll just disappear from that array, which should disappear when I update it. I think I update it down here somewhere. Maybe not. I need to. But the end of the array. So the start is somewhere else, and the end matches up with that point. But the object should be exactly the same. The object's in this placed wire. Vector 3F. Yeah, I use the vector because it is extremely specific to that location. I don't want to use the blocks, like the block position, because you could have more than think of a transformer. Ideally, I would have the selection box indexes, but again, I'm not 100% sure that would all work because of wire types. No, that should work. Start equals end equals start. So if I'm in my block and I'm iterating through the end wires, the wires that end at my position, the start, this wouldn't be true. Now that I'm thinking about this wouldn't be true. Because it's exactly the same copy of the placed wire. Either that or I swap No, I can't swap the start and end because that would really mess up most of my other code. Okay, it might be time to draw this out so my mind doesn't implode. Got my trusty grid paper here. Okay, so start and end. And connect the wire between the two. So this is going to be, let's say 1, 1, 1, and this will be 2, 2, 2. Okay, start and end. Really simple. So wire start will include the placed wire will be 1, 1, 1, 2, 2, 2 on both of these. So start, placed wire, 1, 1, 1, start equals start. And then end, 2, 2, 2 will equal end. That's right. But at the end, when I'm iterating through those, placed wire is still 1, 1, 1, 2, 2, 2. What am I missing here? Is this superfluous? Because both nodes get the same copy of the wire. So I'm comparing the same attributes. Start and end are the same on either side. It's just a different array. The end, so the node that starts at doesn't have an end array. I've got my little diagrams here that I use. So the start, this is just an end, just a different array, but it has the same start and end in it. I think placed other wire, placed wire, placed wire left, placed wire right. I'm literally comparing two placed wires. It's just that the endpoints, I don't think I need this. I don't think I need it. Because there should never be a time there should never be a time when, because the end node, none of the variables are changed. The placed wire object is the same. It's just the end nodes match up with the position instead of the start nodes. The only difference, the end array. So, okay, when I add a connection, that's one of the reasons why I probably am struggling with this, because I haven't completed the routine that adds connection. Right? I haven't completed that yet. Yeah, I haven't completed that one yet. So when you add a connection, let's say you drag from relay A to machine B, right? The relay to the machine. The relay in the wire's start array gets the copy of that placed wire, right? A to B. The machine gets a copy of that same A to B, only it's in the end wires. right? Instead of the start wires, it's the end wires, but it's still A to B. Yeah. It's still A to B. So the start and the end should still match up. It's the same connection. It's just the iteration goes backwards instead of forwards. So I think that was a superfluous check. And I could absolutely make this easier. I just want to keep it like that. It helps when you're debugging to have more lines, because when you're stepping through the debugger, if it's all on one line, that's hard to actually like see what's happening to the variables. Okay, I think that I'm really glad I've processed this. It helps talking through this stuff. I've been spending the last like 3 weeks just brute forcing my way through this, and sometimes I have to talk like through the logic in order to catch major mistakes like that. Okay, so I couldn't think of a really elegant way, if we found a match in an array, to remove just that element out of the array, because there's an access violation that happens if you try to do that. So you literally have to, if you're trying to remove an object out of an array, you have to be building a separate array the whole time and adding elements to the array, and then just skipping the element that you don't want to add, right? That you want to remove. And then at the end, you have 2 arrays. One array is like the old items, and the new array is all of the new items minus the one that you wanted to get rid of. Well, you can't do that in the for statement. You can't remove items out of an array because you're leaving empty space in memory for that. So what I do is I take the array and I convert it into a list, which is a generic typed system for C#, right? I convert it into a list, and that allows me to remove something. So if I look, this cons here, I don't know why, connections. So connections of wire start, this is all of the connections. It could be 0, it could be 1. I need to do a null check at this. Yeah, I'll do null checks. I'll do null checks. Wire start, if this is null, again, null checks are important, because the wire start could very well be null, as well as the wire's end. So if cons does not equal null, actually, and cons not count is greater than 0. How about that? Might as well do this. Okay. If cons does not equal null, if it is null, this will be null. So this is not null if cons dot count is greater than 0. So if it equals null, this will immediately bomb out, because this is an and if this is false, the whole thing can't be in. So if it's not null, then we check the count. But yeah, anyway, it's just smart to do that. And the same with this. If cons not equal null and cons.count greater than 0. Okay. So let's see. That's a little bit safer code. Little bit safer code. Excellent. So we detect the, we find the, in the start node, we find the connection and we remove it. And then we reassign. It copies all the elements into an array and we reassign it. And we clear the array, or we clear the list, sorry. And then we set the wire's end, which is the ending node. We grab all of those to a list. We iterate through, find the connection and remove it, and reset the array there. Then we do drops.count, which means we actually generated drops, right? So the placed wire should not be null with remove connection. If this is null, that's bad. That's very, very bad. And it is an internal connection. So we can't, outside of this mod, we cannot directly call remove connection. Only the catenary mod can or derived variables can call this. If we have drops, right? If drops.count, which it should always be, this should never be null, right? Because we do a new on this. We do a new. So this should never be null. So this should never be null, but it could be 0. So if it's greater than 0, we want to iterate through and drop the entities. And we drop them at the starting location. So if we disconnect a wire at the end, the wires will drop over at the start. Now I could probably drop them in the middle. I just needed to pick a spot. Then we trigger the connection. I'm thinking we probably want... When do we want to mark the dirty? When do we want to mark it dirty? So that block entity.mark dirty. Redraw on client true. Okay, so that call, mark dirty, when called on the server, will resync the block. So what that does is it calls the attributes. Remember, I said the to tree attribute and the from tree attribute that we override from the block behavior. From tree, these are called when the entity is being resynced, as well as loading and saving to disk. This is also how the server communicates and pushes information to the client. This is the mechanism it uses. So we change, in the mod, we are changing the arrays, right? We are changing these arrays. The wires start and the wires end, right? So the placed wires start, wires end, and network IDs. That's one thing I haven't accounted for yet is the network IDs. There's probably a bunch of logic involved with that. Yeah, I probably want to set that ID. If I remove all of the connections from a certain thing, so if the count equals 0, I want to remove that network ID. Anyway, we'll worry about that in a second. So I reset the ending and the starting behavior arrays. I push all of the new data to. Now this is all on the server. It happens on the client too, but we don't care about that. It can happen on both. But when I do the mark dirty, this is when the server pushes the data to the client, right? The client grabs the data, runs the from tree attributes, pulls the new data in, and initialize or resets. If we look at from here, it grabs the bytes because they're all byte arrays. It's the easiest way to do it. The deserializer will convert the array of bytes into an array of placed wires. Now these could be giant, because remember, the placed wire object also holds the mesh, right? The mesh of the wire. So there could be some optimizations done there. If I remove the mesh, I don't know how fast this is going to be because there's so much data being transferred between. I don't know how fast or slow it's going to be. So there's going to have to be some experimentation there. Yeah, the client gets this, reinitializes everything, and then updates itself accordingly. Now, that's what the mark dirty does. Is this will push the data to the client and cause it to redraw, which is what we want, because we literally just removed a wire, which will also or should also call the redraw on the chunk. So if we look at this, when called on the server, we'll resync the block entity with all its tree attribute to the client, but will not resend to redraw the block unless specified. Okay, when called on client, triggers a block change, blah, blah, blah. So I'm setting that redraw on client to true because that will force the whole thing to redraw. And I'm hoping that the chunk is redrawn, or at least rebuilt. That on tessellation should be called, possibly. I don't know. But then after we do that, then we call the event, right? The events, these events that I have, right? These events, the only purpose of these events is to update the networks. So the mods that come in after the fact, like my electric mod, will not bother with the wiring. The wiring is not my concern. All my electric mod is going to do is manage the networks. So it's going to have a network object. It's going to have a master network manager object that manages all of the networks, that keeps track of all of the nodes on the network. Like there's a whole lot of infrastructure that has to be built around the networks and the building and rebuilding and managing the networks. But all of the networks care about is when connections are added and when they are removed. Those are the only two things that we care about, unless somebody out there can come up with another possible reason to call another event, right? If a wire is created, if a wire connection is created, if a wire connection is removed, those are the two things that I care about. The network side of things will assign themselves. They will register themselves as containers or as subscribers. I think they call them subscribers to the events And then, if there is one subscriber or if there's 20 subscribers, it'll just call them until the object is consumed. If you never set consumed equals true, it will call all 20 every time. But if you're a specific network or if you really want to override things, you can just never call that, or you can set that, whatever. But yeah, the network side of things, all we're gonna store on the network are the nodes per network, right? So you'll have a network that has a list of block positions. The networks are going to be dead simple. They're going to have a list of block positions or whatever objects. I haven't really fleshed out the objects for the electrical network side of things yet. I'm still trying to get wiring working. But it's going to be just the nodes that simulate on a network. So the simulation ticks, I want to be really, really clean with how often the networks update, because you could have 20 different networks. One wire here, one wire there, one wire over here. Those are all separate networks until they start connecting to one another. So managing network IDs is one of the things that's going to be rough. Right now, that's one of the things that the OnInteract I need to manage. Which is why, I've got a to-do list going. So this is really the very last thing I worked on yesterday. So OnInteract, again, when you're holding the wire, the block that is the wire, when you look at a block, it's going to show the wire connection points, the wire anchor points. When you right-click one of those, the call is can connect wire that goes to the block. It's up to the block to determine, hey, can I connect a wire? Right? Can attach wire. If this is false, obviously we're not going to attach a wire. If it is true, then we want to attach a wire, which means the workspace gets all of the nitty-gritty details. All of the nitty-gritty details. So can attach wire on this spot, which is the I-wire anchor. Now, the problem, and this again, a lot of this was, see, I have network ID. I've been starting to figure out when I attach the wire, right? When I attach the wire to that, I need to know what network ID to assign it. Now, the network ID could be inherited, because if I have a wire coming in from outside, I could set the ID. So each node, if we look at this, each one of these will have a network ID associated with it, right? So this will be network ID of 1. This will be network ID of 1, right? If I bring in another wire and connect it to this, that wire could inherit the network ID of 1 instead of adding its own. So if I have an existing network ID, I need to grab that somehow. So how do I do that? Well, let's figure that out. OnInteract, we are given the block, the slot, the item or the entity, and the selection. This one is when the not now building, right, means this is a fresh connection. It doesn't mean there are no wires connected to it already. It just means that there's a fresh connection. So we also need to figure out a few things. Wired block and BEH. I've already grabbed these. Wired block and BEH. So the behavior and the block itself, I'm grabbing those. So essentially what it is the block entity itself, the meat and potatoes of a machine, doesn't care about any of this. The block entity can hum along like a generator. A generator can hum along, simulate itself, generating power, regardless of whether it's connected to a wire. So the wiring system will not influence the entity, which is why I have it in the behavior and the block. More or less the behavior. So the behavior holds the array, an array of network IDs. And the way that I do that is the iWire network interface. So the behavior is more specific. So you go from generic to specific. Generic being the block, right? The block attributes. That's generic. More specific is the entity behavior, right? This is more specific than the block. So this can hold an ID because we can save that ID. Now, again, there's one ID, and I have a network ID in here. Basically, this is just to remind myself. This is the object that holds the ID. It's actually, when it saves to disk, it's actually in the attributes of the block entity, and it's all sorts of, there's layers. There's so many layers to how these games work. But the network ID is part of the behavior. And there is only the number of items in this array as there are numbers of wire nodes. So one wire node means there's one network ID. Regardless of how many connections it has, there's only one ID associated with that. So part of the iWire network is just a set and a get. So I have a set network ID and a get network ID, and they're based off of the selection indexes. The selection indexes, again, are these. This is the selection index of 0. This is the first item. And so the 0 item it's the default because there's going to be a lot of things that only have one connection to it. The selection index is 0, meaning this is the only item in there, which means I need one network ID. So in the behavior, I have a get network ID. Okay. Now, if the network ID does not exist, get network ID does not exist, I return the min value, which is a very, very large negative number. I don't know how common this is, right? So the long.min value, longs are network IDs because they can be they're 64-bit numbers. They can get really big, as you can see by that number there. So if you call this, right, give it a selection index, and it returns min value, there's not a network ID associated with that index, right? So what we do in here, can attach wire. If this is valid, right, it's valid, let's connect it. If not wired block, the BEH, the behavior, BEH dot get network ID, block selection dot selection box index, equals long.min value. which means we don't have a network ID associated with this connection, right? How do we want to do this? A pending connection. A pending connection. Let's say not equal to min value. Because I don't want... How am I going to set the network IDs? Because the network IDs... Again, the catenary mod does not care about network IDs. All it cares about is the wiring. So I'm going to be pulling network IDs. bh.network ID, get network ID, from the block selection index, which is the little index, which is the little, if there's a selection box around this. So here's a look at the block here. So there'll be a selection box around this. So you'll see this like dot, dot, dot. So there's a selection box around this. Oh my God, mouse? Really? What is going on with my mouse? So that's a selection box around that, and then there'll be another one around this. Right? This will be probably 0. This will probably be 1. If I'm holding the wire, this is defined by the behavior. This is defined by the block. And I only care about that. And so the can attach wire, that is the call that the wire item is allowed to connect. Right? So the whatever mod overrides that probably have dust. Yeah, I've blown it out a couple times since it started doing this. I'm not 100% sure not 100% sure why it does that sometimes, but I don't know. Maybe I should get some rubbing alcohol and try to really clean it off. Okay, so if the get network ID, well, let's do this. Long net ID equals beh.get network ID block selection dot selection box index. And then I just do ws.net ID. Now I'll start net ID. Yep. I am working on getting the catenary, getting the wires, right? Getting the wires working. So this is the on interact. This is me holding wire, wired block wire is what calls it, right? So on interact, so I'm holding the wire. I'm looking at a wire connectable block, and I right click the node. It calls the on interact in the catenary mod. So I go to the catenary mod. This is called whenever you interact, and so there's a lot of stuff in here, a lot of logic that has to get done. So I'm grabbing the network ID from that node. If that network ID does not exist, it will set this to long.min value, right? Get network ID, not block wire, wired behavior, I think. No, it's the wired block. There it is. No, it is the behavior. That's the wire tool. There it is. Get network ID. Okay. Get network ID. If selection index equals return long about min value, otherwise return network IDs that selection. Now here's the problem. Where do I initialize? I initialize that array two different places. Initialize. This method is called, I copied this from the source. This method is called right after the block entity was spawned or right after it was loaded from a newly loaded chunk, if you have access to the world and its blocks at this point. However, if this block entity already existed, then from tree attributes is called first, right? From tree attributes. So, if base block does not equal null, where does base block? Okay, get block as iWire anchor. And network ID is equals null. There is this will initialize the length of this array with the number of anchors in the block. So if we look, there's just one anchor in the block in this test generator, which means this will just be a 1, right? This will return a 1. This will be a network ID, an array of length of 1, which is fine because there's just one node. It doesn't initialize the value, so the value defaults to 0. I believe it defaults to 0. So when we return, when we get the network ID, wherever that might be, there it is. Right? If it's a brand new block that has never been interacted with before, network IDs.length, it should be fine. Your selection index, again, should never exceed the length. If selection index, let's say it's 0, length is 1. If selection index says is 1, this is still false. But if the length is 1, okay, so I need an equals there. Because this is 0 based, this is 1 based. That's the problem. It's a big confusion. I remember when I was programming, when I was in college, 0 based arrays, I mean, so many people in class were confused by 0 based arrays, where 0 was the first element. So yeah, this is a 0 based, this is a 1 based, so we have to make sure. So if it's out of bounds, it's min value. Otherwise, it's going to return either a number, some number, or 0. Do I care? I don't think the Catenary mod cares which number it is. Right? If it's long.min value, that's an error. But at this point, I don't care about that. It should really never happen. I have so many checks coming into this. The selection box index should never exceed the number of nodes in the block. Period. Yeah, it should never exceed that. I'm just going through like a bunch of scenarios in my head. I don't because if I'm holding the wire, then the nodes, the wire nodes are highlighted. I could go back to the wired block. Where is get selection boxes? Remember, we covered this a little bit ago. Does the block have a side for input and output? Where power is, it doesn't care. Wow, this is just generic wiring right now. Well, this is not. We're not moving things. We're just worried about how to run these wires in an efficient way and render them. So yeah, we're not even in the power system yet. And the power system is going to be very basic. I have enumerations here for the power system. We have electrical power tier. We have electrical entity type. Consumer, producer, storage, transformer, toggle, and other. So toggle is like a power switch. Basically, it's like a transformer without any storage, right? Transformer is connects, more than one network, and it'll have power storage. And the toggle will be able to just connect or disconnect two networks. And then these should be pretty obvious what they are. But yeah, I'm anxious to get into this, but I'm really making sure that all this stuff is right. So we could detect, just like we detect here, when we have a wrench, enum tool wrench. So if we're holding a wrench, only give me the wire connections. If we could do something similar, yeah, I'm really trying to. I mean, this is why I've been spending 3 or so weeks on this, is because there's a lot of really specific things that I need to make sure are done right. Okay, so if I take this, okay, and now I want to move this up to here. The scope of the variable has to exist down here. So this could add it. Okay, so if client, right, and then this return will make sure that if we're holding the wire tool or any wrench, that this will it will not get any here. But then we need an if here. If API as iCore client API .world.player .inventory manager .active hotbar slot .item stack .item .block block, because the block wire, this is the wire. It's extendable. You can add, this is the wire block. You can add via other mods. You can add variant groups. You could add different shapes. You could change the attributes. You could add attributes. You could change pretty much anything in the JSON with patches. So I'm trying to make it very, very extendable. If people come in here and say, hey, I want an applied energistics wire, very specific, you could add something in here that would be a very specific wire type. You would add then a new shape, then you would add new attributes, and it would just load in based on that. And you can even do class by type, right? You could do class by type and say, I could even do that. Class by type right now would be star, would be one type, but then I could probably, if you could add class by type, you could add an entry in there for your specific class, and then it would inherit that. But you would have to inherit the block wire, right? You would have to inherit from this for the system to actually detect that it is a block of wire, right? So where is it? Wired block. This block here, right, equals block wire dot type of this is a stack of blocks. This is otherwise no block dot code. First code part. Really? You're gonna Jesus. Oh, that's a call. I believe this is lowercase. Yeah. So catenary, it will look, whatever the block is, if it's equal to catenary, if it's not null, if it is null, doesn't matter. Okay. So this, if we're holding the wire, the catenary, which is a block, right? This is a block. If we're holding the wire, only show me the wire anchor. Return boxes.toArray. Okay. So world.player.inventory manager. So the client API, anytime you're interacting with, showing the GUI of, anytime you're doing stuff like that, you're always in the client API. The server never has that going. Yeah. So basically what this does is, if we're holding a wrench, then only show me the wires. The wire collision, right? The selection boxes, only show me the wires. If we're holding the actual wire itself, which is a block. I know it's confusing that it's a block, but I mean, it's a collectible object. It doesn't matter. That really doesn't matter. If we're holding the block, then, or the wire, show me the anchors. The rotated copy means these. It inherits from these, the rotations. And I don't 100% understand in my head how that works, but it's important that you have those. So the rotated copy is taking the base, it's taking the anchor, right? This definition, and it's giving me the rotation by type. Whatever rotation this has, is that rotated copy. Right, which means while you're in the game, it'll automatically rotate, the selection box to the, hopefully the proper spot, and then we return just the anchors. If we're not holding either if we're not holding a wrench, and we're not even holding the wire, then give me the base selection boxes, which means it will return this as the base. This is what this is basically the whole block. So in this case, it would allow you to be holding a pickaxe to break the block without getting all messy with all of the different things. Shows the wire icon in the inventory in the model in your hand. Let's see. Shows the wire. Yeah, the wire, if we looked at the wire, I doubt the texture will show. Vintage story. I want to... Oh, I hate when it does that. This, programming, vintage engineering, mod, assets, vintage. Oh, I think that was in game, shapes, block, wires. So, like bare copper, right? So this is the bare copper block shape. It's not showing the texture. It is copper. Because in the shape file, I had to set up this. I had to put the domain in there, and that's why it's not showing. But it's just it's bare copper. So every wire type has that, and that's the texture that it's supposed to be using. That's why I did it the way I did it. Again, I'm basing it off of the support beam system. And that's how you can have a beam of, purple heart and a beam of pine and a beam of, maple, and they're all different textures because they're separate blocks. The block system rendering is different from the item system rendering. Because items, while you place a lot of them on the ground, they're not really set up for like textures to render in large, batch jobs. So it's just a lot easier to do this. So this should, when we're in game, distinctly change what selection boxes are shown based on what you're holding as the player. And because we're doing the code of the catenary, means this is the code. So the full code is catenary dash LV power, catenary dash MV power. Those are separate blocks. Catenary dash HV power. Each one of those has a different shape. There's LV and MV are bare copper. HV, EV are insulated. All power is insulated. If you want to create a mod that just didn't care about power like limitations, signal red, signal green. Each one of those actually has the wire is actually red and green, and then communication again is insulated. So you can change these textures if you want. You can create custom textures. You could create custom shapes with custom textures. It's all, essentially, you can override anything in the mod, suit whatever needs you had. I want to create something that Tyrone can integrate into the base game that everybody can use. Will it connect to transformers to transfer the power over a distance, or just directly from power source to machine at a distance? The way that I'm going to set up, and the catenary, this has no bearing on the power simulation at all. This is just the wiring, and we have network events. We actually have events on wire connected, on wire removed, that are called when a connection is made or a connection is removed, and it's up to the network mod to adjust their networks on that side. But to answer your question, when I do get the network, what I'm hoping to in the next week or two, I'm hoping to get to the electrical network stuff and get this wire stuff behind me. Yes, the transformers. Okay, so how I'm going to base it? I'm basing it loosely off of the immersive engineering mod. This whole mod is based off of the immersive engineering mod, very loosely. So what is going to be is each tier of power. If we go back to the enums here for the power, each one of these is going to have a limit on how much power can be held on a line, right? I don't know what the numbers are. I don't know what the balance is yet. That comes much later. Much later, the balance of everything. But just for example ideas, just examples. Let's say LV. Oh my God. What is... My mouse just decided... There we go. There's just random buttons on my mouse that change how slow it is. Anyway, so let's say LV power has a limit of 256 power that can run on a line, right? 256 power. And let's say MV has up to 1024 power, right? Now a machine will have a certain power, right? A machine will be also the power tier. So if a machine is labeled LV as the tier and you put MV power into it, you could have bad things happen, right? So you need a transformer to go from MV to LV. And so the transformer itself, and this is how I'm going to set it up, the transformer itself is going to have an internal storage buffer of power because of how the networks are going to be simulated. Because a transformer, if I could do it visually, okay, a transformer, let's go purple square here. And they're going to be, they have to be like single blocks. We can't have crazy things happen. So there'll be a node there, and there'll be a node there. Okay. A transformer will have an internal buffer of power. I'm running out of colors here. And let's say a brush. Let's say it's this full. Okay. So we'll have a power line coming in here. And a power line. Oh my God. I don't know why you have to click twice. Okay. Imagine that looks better. Okay. So a transformer will be a block that has 2 nodes on it. Each node will have a different power tier. So if we look at sorry, my voice is going. It will be a block just like my test machine, but there'll be two entries into here. One entry will be power, or they'll both be power, and they'll each have 1 max connection, but there'll be 2 of them. Up here, you'll have name, block behavior, electrical connector. You'll have wire nodes. There'll be 2 wire nodes in here. Index 0, let's say index 0 is this one. Index 0 will be labeled as MV. Index 1 will be labeled as LV, right? And there'll be an internal buffer in here. And so that's part of the block entity. That doesn't matter. But wire-wise, strictly wire-wise, this one will be labeled MV, and then this littler one will be labeled LV. And there'll be 2 separate networks. The MV network will fill up the buffer. If there's space in the buffer left, it'll add power, right? That's why the enum the transformer is its own type because it's such a specialized thing. Now, you could create a network, you could create an electrical mod that uses all of these, that uses all of my code, but just ignores all of this and is like an RF system, right? The RF system, it doesn't matter. It is power in, power out, doesn't matter. There are limits on how much power can be transmitted, but the machines themselves don't explode if you have a power connection to it that has 1,000,000 power in it. It doesn't matter. This system is a little bit more ingrained and in depth, and I think it matches a lot more the Vintage Story vibe, where you have a power coming in, and so MV power can transmit, let's say, 1024 power, right? 1024 power per second, whatever it is, 1024 power per second. All right, so you have 1024 power per second, and then the LV is 256 power. So technically, an MV cable could supply 4 different LV networks with power, right? Which means you'd need 4 transformers like that. The machines connected to this, you would have as LV machines, which means you can have tiers of machines. So if you go back to the original, like, first or second streams in this mod, I forgot to add this stream into the playlist. I'll do that after the stream is over. But I have a playlist for this mod. The very first stream is me talking about all the features that I wanted to add. And the second stream is talking about, like, how to implement that. Anyway, so the tiers of machines, you'll start with the low voltage machines. And then the top tier machines, like the big arc smelter, right? The giant arc smelter would be like, that would be like an HV machine. You know, you would have to have, let's say an HV is like a 4096. So you have 256, 1024, 4096. So you'd have to pump 4096 power per second into the arc smelter. Well, you're going to need a whole lot of power generation for that, right? And so the cables, all the wires, as you build up, if you noticed, one of the things I did for the catenary is the thickness wires. So LV is literally 1/16. It's 1 voxel in the game. This is 2. This is 2. This is 3, right? EV power, extreme voltage. So a mod could come in here later and change these values to whatever they wanted. I'm really trying to be as extensible as I can. But it would mean that you would have to supply enough power. So on the generation side, the transformers can go both ways, right? They can go both ways depending on what is on either side of the transformer. Transformer can go up in voltage or down in voltage. So you could have, let's say, 4 generators that are all LV generators on one LV line. Those go into a transformer. They're filling up the buffer, which goes to the MV. Then this 1024. Or the other way would be a bunch of machines on the other side of the transformer drawing power. The electrical network, all it's going to do is it's going to be limited in number of simulation ticks per second, but it's literally going to decide what power is available, what power is needed, and what power do I have, and it's just going to distribute that based on a priority system. It's going to be very dead easy. It's going to be very simple because it's all you need. It's like, here's how much power I've generated, and here's how much power I've needed. And the higher priority machines get power first. The higher priority generators get removed power first. I'm going to have a priority system built into the system. But again, I want to build the system so anybody can use it. I want to be able to have anybody be able to use this system to add all their own machines, to add whatever new mod that uses the electrical. So the mod is going to have, yes, it's going to have the electrical system, and I'm gonna try to work with Tyrone, the developer, to not only integrate the Catenary mod so anybody can use it, because again, the Catenary mod has the ability to have many types of things. Power is just one. You could have signals, communication, whatever else, right? So I want to be extensible. So I want to have this added to the base game as well as the power system. It's just the amount of work it takes to create a system that's very extensible is a lot longer than a system that's hard-coded to what you need and just what you need. So that's why it's taken me so much longer to implement these systems than it would normally be. So if we get back to the Catenary mod, no, I didn't close it. It just went off the screen. Okay. Let's render frame. So the custom render is only done when when you click a wire and you're holding the wire, that pending wire is going to be like ghosted until you click it again. And I haven't gotten to that. So you click the wire. The wire connection is valid. Let's connect it, which means I set up the workspace and I say, here's the start position, which is the block position. The start offset, which is the very specific vector of the offset, right? So the get anchor position, when you specify an anchor, this anchor, this is a square or a cube. The specific wire connection point has to be a single infinitesimal point. So what I do is I return the call, get anchor position, depending on the selection box. The call returns the midpoint of that cube, basically the center point. Doesn't matter what the variables are, I want the center point of that. That's what is returned. If you have experience with the QP Tech mod, when you connect wires in that, his connection point is hard coded to the very center of the block, which is why the wire sort of goes into the block at willy-nilly places. The start index, this I'm storing these selection box indexes. Again, the specific selection box is a zero-based array of the wire node anchor points, basically the wire anchor points, which could be just one. It could be a zero. Zero. Start with network ID. Then again, I grab. We just put that in there. Block select.network ID. Again, the Catenary mod does not care what network ID it is. It just doesn't care. But I wanna grab it if it exists. What I should do. Okay. I'll worry about that in a second. Okay. So we get the thickness, right? So the attributes, the thickness, even though I have the shape, right? I have the shape, the default shape done, and it's in the shape file. When I generate the wiring, when I generate from A to B, one of the variables I can change is how thick the wire is. And that defaults in here. So that is passed down the line via the attributes of the block, right? The block is what I'm holding. This is the wire that I'm holding. Remember, this is the wire that I'm holding. Right? So it will be catenary dash like LV power, which will have its own attribute of thickness 0.625 or 0.0625. So that's will be this. If there's an error in this, then I default it to this. Okay, so then that gives me the thickness of the wire, and then the wire function, right? The wire function is also the attribute. And the as object, well, is it just converts this text to the enumeration, the wire function. The block equals the block, which is the wire that we're holding, right? That essentially gives me the texture. I haven't figured out exactly how the texture is used. I have to look at the base game code again to figure that out. The now building, this is the call that determines whether or not we're in the middle. This call triggers the renderer. Setting this to true triggers the custom renderer in this mod. So the mod itself is actually has a custom renderer, and it is based off of the now building, which is also only a client side thing. And then the end offset equals null, which means it's pending. I right click this block. I don't have an end yet. So the end is null, and then we return coming out of that. If not building. We don't want to go if we're in the process, none of this other stuff matters, because we're in the process. We can't right click a connection and then right click a connection and loop it to connect to itself. That's an invalid connection. Okay. Now here's what I was working on, and this was I was kind of right in the middle of working on last night. Okay, so we are currently connected to a starting position, but if each of these are null, bounce. Don't do anything, because that means we're not looking at another connectable block. Just bounce. If start position equals what position we're looking at, right? If we're looking at the same position, then bounce. Because essentially, when you right click a block, in the very next frame that's rendered, you're still looking at the same block, and you don't want it to do anything. Or if you're stretching a wire around, you don't want it to do anything. Okay. Wired block can attach wire. This again is called, so now imagine you're looking at a separate block. We right click this block, we right click a block over here, and now we're moving over to here and we're looking at this block. Now we're looking at a separate block, and we're looking at a separate selection box on this other block. So now we need to check it again. Can we attach the wire to this block? And if this is false, bounce, which means we can't connect it to there. A lot of these are on multiple lines because it's going to be a lot easier to debug. Because I could just put a return on the end of this and call that a single line, but it's hard to debug when it's that. It's a lot easier as far as the flow goes to just kind of follow it. There's one other thing we need to check. And that is the length. If this is true, then we can get here. So if we are here, we can connect wire. If we're here, we can connect wire. Right? Okay. So if we're already here, we can connect the wire. Now we need to figure out what we need to do. So if first of all, let's check network ID. If beh.get network ID block selection index yeah, I know there's a bunch of errors. I wish it would be a little bit more patient and not give me errors, right away, because so if this network ID, well, let's do this. Long net ID equals, okay. If net ID equals 0 or net ID equals long.min value, not equal to 0, not equal to min value. Okay. So if it's equal to 0, remember, we're looking at the new block. The old block, we already grabbed the network ID, right? So the old block network ID and the new block network ID. So the ws.net ID, right? That is a thing. Now, the other thing we could probably do, let's minimize that, that, and that. Get or create wire mesh, get and offset, no. Trigger add connection. Okay. I actually want bool ref consumed. Okay. I'm thinking. The catenary mod does not care about network IDs. It's not going to manage network IDs. It's not going to do anything with network IDs. But it has to track them, right? It has to track them because as you're adding wires, what you could do when you add the connection, when the event fires, you you could return back out the network ID from whatever gets it. So we could add, let's just see if this is possible. On wire connected delegate out long network ID. Okay. That's going to be some errors, so not worried about that. We're going to go here. Out long network ID. out. For each wire connection. There we go. The out command in C#, it's basically passing by reference. So it doesn't matter how deep into the stack you run, it's being passed by reference, which means if you change it, anywhere in that call line, in the delegate array invocation list, if it changes at all, when it comes back to here, it will be changed. It will whatever it is, it will be changed. Oh, my nose. Must be assigned to, yeah. This is where I sort of like, my brain just kind of like, what? Let's remove connection, add connection. Let me look. Checking chat. The power and over distance. The distances in the game aren't long enough to really, like, if the wire is so long that it's so far away, it's probably not even loaded. It's not even rendering the network. Like, if a piece of the network is unloaded, I haven't run into that yet. I don't know what happens. It'd be an interesting test. Should ask us to test that on the server. Like, have a mechanical network go so far that part of it unloads. Right? So you have a windmill. You have a windmill on one side. Then that you have a shaft that goes a long ways away, like a long ways away, and then connects to like a current. And then if you're standing next to the windmill, the current won't be loaded. If you're standing next to the current, the windmill won't be loaded. How does the game handle that? If something is unloaded in the game, yeah, it's kind of bad.
Yeah, I don't think it would work in those instances. But whether the distance reduces it or not, yeah, I guess I'm not sure.
Well, yeah, that's just it. Is I don't think it would reduce, but I do think it would not work because the other end is not loaded. So the windmill, when you're on the windmill side, you would see the windmills move and the shaft would be turning. Everything would look like it's working, but the current wouldn't be running. If you're on the current side, it wouldn't be running regardless of the wind speed because the windmills would be unloaded. So the power wouldn't go. There is a function in the game that allows you to chunk load stuff. But it's been like I have no idea how well it works because the chunks in the game are different than Minecraft, right? A chunk loader in Minecraft is the entire column of the world, right? That's the chunk that's loaded. Vintage Story is cubic chunks, not columns. So if you force load a chunk in Vintage Story, it's just the 32 by 32 by 32 square around you, right? It doesn't go all the way down to bedrock. So, and it doesn't go all the way up infinitely in the sky. And so you could load a chunk, like let's say you load let's say you build a windmill that's 60 blocks high. So you're standing on the ground and you load that chunk. Well, the windmill is 60 blocks high. That's not loaded because that's a different chunk. So chunk loading in the game is a little bit different. And I don't know what the long-term impact is or what the effect is going to be on the mod, because that might be a problem. It might be a problem. Okay, so trigger add connection. Very, very simple. Add connection. Now, where are we at? That was remove connect. Yeah. Let's go up to here. What is this? Oh yeah. I don't care about network ID. I really don't. So let's go to here. Get network ID. Wonder if somebody made a chunk loader. I don't know if somebody made a chunk loader. I think maybe somebody has tried. I know there's a claim system that somebody built to like claim chunks, but I don't know if they did a chunk loader, and I don't know what impact that would have on the game. I'll have to, wait on 6 months from now. I'll probably run into that problem. There might be code that you can add to a machine, like a block entity that just says, hey, keep me loaded. Keep me loaded and keep me running. Keep me simulating. You don't need to render me. You don't need to render it. Just simulate it. Because I know when you walk away from your boat, let's say you put stuff in the fireplace to cook, and then you leave your base and you go out exploring. You come back, that stuff is still in there cooking. It hadn't finished yet. Because as soon as you left, as soon as it unloaded, it stopped simulating the fireplace. That's the problem. If you have generators that are way far away, they might be unloaded, not providing any power. That's the problem. If I can override that and say, keep me loaded, you don't necessarily have to render everything, but just keep it loaded and simulated. I don't know. I'd have to talk to Tyrone about that. I'm hoping he's open to, I don't know, expanding things, changing things a little bit. Because up till now, there's not really been a big reason. Like, you have windmills and stuff. That's not, yeah. People haven't built extensive bases that they usually do in Minecraft. Okay. So I don't care about the network ID. Get network ID. It's going to get it whether we want it or not. I don't think it matters because the connection itself is going to be, it's going to give me the network ID associated with this. So I think we're just going to keep this at 0 or -1. Sure, -1. Everything else is fine. All right. So let's continue. I don't really care again about network IDs. Let's just ignore that completely. There's the network ID right there. So new connection equals placed wire. So start offset, end offset. End offset is set on render frame, get end offset. ws.end offset equals now offset. So This here is rendered every frame. I want to create a bounce, right? A debounce. This is something that the debounce, I don't know why it's called a debounce or just a bounce. This is something I picked off of DJ's code in FortressCraft Evolved. He has a lot of debounces in his code. Essentially what a debounce is, as you can rightfully imagine, is it's a timed system to limit how often something fires. So I had to add debounces for like my excavation mod, because when you would hit a hotkey, literally that hotkey was firing every single rendered frame, right? So you'd hit a hotkey and it would go like, it would just like hit it really, really fast. So I had to create a debounce in there that would only fire it, which is why you have to like, when you do the commands, you have to do it in a, like, you have to delay it a certain amount, because there's a debounce in there that prevents it from firing 100 times, 60 times a second or 30 times a second. So I want the render frame to not render every frame, because one of the things that this does, right? So imagine yourself, you're holding the wire block. You walk up to a block. It shows you the wire connections. You right-click it, right? You right-click it. The connection is made, and now you have a pending wire connection. Now, every single frame that you're holding that connection, there's going to be a ghosted wire frame of that connection. And you can look at this. This is the same kind of code that's in the support beams. You click the support beam on one block, and as you stretch it across, it's rebuilding that 3D mesh. So it's redoing that. It's calling that code over and over and over again, every frame. That is way too often, right? It's 30 times a second, 60 times a second, way too often to rebuild the 3D mesh that we're talking about. Because there's a lot more code behind my mesh than like support beams, which are essentially just long rectangles versus a wire. So you have that ghosted model in front of you. As you move around the world, that model is being regenerated. Now, I ran into a massive bug when I recorded my finally recorded the showcase on my building gadget mod. I ran into a bug that was a memory leak because I didn't dispose of the highlighted blocks every frame. And if you were in the build to me mode, right? The build to me mode highlights the blocks. So you're looking at this block, it'll highlight the blocks up to your face. You move 1 pixel, it regenerates that, right? And I didn't have I had forgotten to do the dispose before I regenerated it. So it would regenerate it, and the memory of the old version was leaked, right? So you would move back a couple blocks, and in that time, because it was every frame, the game was taking like 24 gigs of RAM because of how often that was run, which is bad. You don't want to do that. So I want to limit how often this gets generated, because the garbage collector, even though it's going on behind the scenes, the garbage collector is not fast enough to collect gigabytes of memory that fast. So I want to bounce this every half a second. So as you're moving around, like the rendered wire will like, it will jerk. So you connect it, right? It generates it. You move away. As you move away, the thing is going to jerk to you. You move to the side, it's going to jerk to you every half a second. I think a half a second is fine. I mean, I think it's fine. If it's not, then I can always do that. But the debounce here, the delta time, this is the fraction of a second. So what we're going to do is we're going to add up here, we're going to do a private float. This is a client side only thing. Doesn't matter. Render bouncer equals 0. Okay. Render bouncer. Part of this, it's just a private local variable, or local is probably a misnomer. Okay. So what we do is we do render bouncer plus equals delta time, right? If render bouncer is less than 0.5, maybe less than or equal to 0.5, return. Otherwise, render bouncer equals 0. This is a debouncer. A very simple bouncer, right? It won't run any of this code unless the bouncer is over a half a second, the delta time. So the delta, remember, this render frame is called every single frame. So the delta time varies depending on how long it takes a frame to process. So a very, very complex scene will take 0.25, 0.38, 0.42, 0.14. Like you'll have varying amounts. We'll be adding those to the render bouncer, right? As soon as the render bouncer, as long as the render bouncer is less than or equal to, let's do less than. Why not? Less than 0.5. Return. As soon as it's greater than or equal to, it goes to here, sets it back to 0, and then updates itself, right? It renders, it doesn't, it'll actually render it, it'll update the mesh. All of the things happen, right? All of the things happen, all in this step, where it gets the end offset, it updates, it updates the offset. Basically, the get offset, if you're not looking at a block or a valid block, the endpoint is like in front of the camera. If you are looking at an endpoint and you are looking at a valid endpoint, then the end offset is the valid endpoint. So if we look at, we pass in the player and the workspace. If we go to this.getEndOffset, let's go to definition. This right here is a fairly simple thing, right? It's a fairly simple one. There's a lot of cross calls in here. But by default, the vector is entity.sidedPosition.ahead copy. So wherever your position is, ahead two squares. Okay. .xyz.add local I position, so it's subtract. So there's some math involved, but essentially it's trying to put it like in front. So this is the default. If any of this fails, then you return in front of the eyes, right? If any of this stuff in here fails, just give me what's in front of the eyes. Otherwise, current block selection, right? Player, I pass the player in. If they're looking at a block, means this they're looking at a block. I'm grabbing the block. If the block is a wire anchor, right? The selection box index is valid, right? Selection box index is greater than or less than number of anchors in block. So if the number of anchors is 3, this will be 0 to 2, which is what it should be. Number of anchors in block. Can the wire, and then this is one of the most important calls in the entire mod, and I don't have any implementation that's actually valid yet because it's all been abstracted. So can attach wire is the be all end all. This is depending on what mod is in place. Can attach wire. If it can, then get the anchor position, which gives you the center point of that position, and that is what we return, is the vector 3f, basically 3 floats, the offset, three-dimensional offset inside of that of the anchor position, which is again part of the wired block, which is the midpoint of the rotated copy. It all just cascades. This is another reason why I was just like, this is why it's been taking me so long to like grind through this, because man, there's so much to think of. Get end offset. Where am I at? Okay, so this is the bouncer. This is what sets the end offset. This is the shader. Again, no idea what the code. No idea what this. Like, I can guess. I can look at it and read it, but like shader programs and model matrices, identity, translate. I have no idea if these are even like rendered. It's just, yeah. There's a lot of like matrix math is literally what drives game engines, and not my forte. Okay, so this also checks on render frame. It looks like this is also checking the distance, and it's comparing it to the max length, right? So if the max length here, distance 2, which is a pretty expensive call. This is one of the reasons I wanted to do a debouncer. Anytime you do a square root, which is a distance, 3-dimensional distance, anytime you do a square root, it's an expensive call. But if the distance is greater, right? If we're standing start offset dot distance to now end offset, which is the end offset, if it's greater than the max length, return, which doesn't reset it. So in my mind, I get to go, oh, thanks for coming by. Have a good one. Have a good Wednesday. So what'll happen in my mind, this is, again, I haven't tested this yet, but you connect the wire to this node. And then let's say you're backing up, and the wire every half a second is following you. The moment it would exceed the max length of the wire, it stops updating. I want to try to highlight it red, like keep updating, but highlight it red. I don't know how to do that though. Somebody could probably, once the code is public sometime next year, I'm sure there's a ton of little extra features that you could add to this. But I'd like to have it like turn red and not be allowed, but for now it just stops updating, right? The wire, you would have a distant wire coming at your face, and you would get further and further and further away, and it would stop updating, right? Because it's too far, the max length. Now, that's why I'd like to tint it red, because that's a little bit more of a visual. I mean, somebody might think the game, like the system, broke if it didn't update, but I wanted to include a max length feature. Now, if you could set the max length, I mean, they're literally as integers. So you could set the max length to 255, right? Or 32,000. It wouldn't matter then. It would be an infinite length that you could run. That would probably be pretty bad, especially for going off of rendering distance. Okay, so this already accounts for the distance, the max length of the block. So we don't have to worry about the distance. So if we're here, we can connect the wire. So the placement, the wire let's create the connection. All right. Now we want to run the event. We want to trigger the event. On remove connection, trigger. Yeah, we want to trigger, because one of the things that we're going to get back from that is the network ID. Right? So here's the new connection. I think the trigger connection gives us the start and the end. One of the things I could do trigger add connection. I don't want to pass. This is the tricky part about this. I don't want to pass the placed wire object, because one of the things the placed wire object has is the mesh that is the wire, and that could potentially be a big object depending on how big the wire is and how long the wire is. That's a lot of information to put on the stack that you're then passing to very different materials, or very different, plus all the other things in the placed wire. Like, there's a lot of variables in here. Block positions, functions, vectors. Like, there's a lot of stuff in here in addition to the mesh data that I think wouldn't work too well. Where am I at? Did I just... Yeah, so I don't think passing this new connection get end offset. I thought I closed all of this. Okay, trigger add connection. Start end index, slot consumed, and network ID. So, long net ID equals -1. Now, so the can attach wire. So all of the stuff that we have on top of this is all to verify wire functions, and like, this can attach wire is such a vital thing because this verifies the wire can be attached, and it's up to the mod, whatever network mod exists, to give me that go ahead. So the network ID. So we create the new connection. The mesh here is the current mesh, which is updated. So essentially, as we're moving around, the mesh is being updated. If we then look at a wired block and we can connect to it, the mesh is already done, right? Because we're looking at a block. All of that is done. So whatever mesh is pending, that's a valid mesh. So we just want to save that. Whatever mesh that is, we want to save it. I might want to do a clone here to get a copy of it rather than a reference of it. So that saves the mesh. So now we have the placed wire. Vector 3. Do I need to clone all of these? I don't even know. That's an integer. That's not a reference. Thickness as float. That's not a reference. Block position dot copy. Block select dot position dot copy. start index. That is a int. That's an int. All right. So that should create a good copy of all of the variables. Then we want to trigger add connection. All right. And so now we want new connection dot master start new connection dot master end new connection dot start selection index new connection dot end selection index item slot is, didn't we pass that in? Yep, slot. Bool ref consumed. Out net ID. What? Why is weird? Okay, I don't care about consume. The trigger add connection. This will run and say this will add connection. Right? This is broadcasting the event where mods pick this up and reorganize their internal networks according to what connection was just made. And then the variable coming out of that is what network ID is associated with that. So that then I can say new connection dot network ID equals net ID. Right? So that will automatically set the network ID, because these are all public. Just the easiest way to do that. I know it's not very safe, but new connection.network ID. So now we're getting a network ID out of that. So whatever network, even if it's a new ID, it should always be greater than 0. Never, ever, ever use a network ID equal to 0. I should, in fact, do iWire network. Okay. Never, let's see. Network IDs should always be greater than 0 and always be greater than 0. Never 0 or negative. I know it limits the number of valid IDs to about 9 quintillion, but negative network IDs. What was that?
Only?
Yeah.
Jeez.
I mean, it's only 9 quintillion network IDs. So you got to start at 1 and work up from there. So, or just randomly generate a GUI ID. That's another way to do it. I'm sure there's something in the API that does that, but yeah, the trigger add connection will return me a network ID. Now we need to actually add the connection, right? Now we need to add the connection. For now, it's like we're not connected to it yet. So now what we can do is we can add a internal void add connection, and we can add placed wire which holds, it should hold all of the information. the start and the end, all of the things, even the mesh, everything in there should be exactly valid. Even the network ID we now have, and we now can push into add connection. Okay. So this, then we want to just pass the duplicating should also be can attach wire. There should be some functionality in here to make sure we're not duplicating the wire. So add connection, new connection. And then where's my mark dirty? Mark dirty, mark dirty. Okay, BEH. Well, I can do that. Yeah. Let's do that in the add connection. Right? Internal void add connection. So I want to kind of replicate what I do here in here. And instead, this is to be placed wire. Okay. Oh, the other thing we need to do, yeah, here we go. One thing I almost forgot is making sure making sure we have enough wire in my hand. If I have 2 wire and I'm trying to stretch at 8, then I need to throw an error. And I believe there's an allegory to this in the support beams. Where would it be? Where the heck is it? BE behavior support beam. Oh, it's in the mod support beam placer. Generate mesh. I don't think it's in there. That's a static. Get end offset. Nope. Not in get or create. Cat? Seriously? What time is it? Must be about 5. Almost. Oh my god. Like people don't realize I'm streaming. Do you want to come up here, Cat? Are you lonely again? It's so funny. She watches my hand. Doesn't matter what I'm doing. You'll watch my hand like a hawk.
Of course, that's where treats are created.
Yeah, exactly, right? There she is. Here we go. I smell like coffee still. Okay. In here somewhere. Trigger in-game error, right? It's in here somewhere. There it is. Okay. Let me push this over to another monitor. So int length equals math.ceiling. No, and we have a bunch of I think yes, you have this here that they have it in the interact and not in the render frame. But I put it in the render frame so I could bounce as much as possible. I want to run this routine as few times as possible. So this here, distance 2, which means it's too small of a distance. If I bounce there, I bounce at the max length. Now end offset. So if these two are not equal, basically you haven't moved a pixel on screen. That's the change there. This reload mesh ref, this is the thing that regenerates the mesh. This is the expensive call. Okay. This dot end offset dot distance 2 ws dot start offset. Okay, so this is the length of the wire. If slot dot stack size is less than length. Okay. If happy trigger in-game error. This not enough items. Text. You need length wire. You need to place to connect points. Return. Okay. Slot dot stack size less than length, which means we have, let's say we have 3, but we need 4. This will trigger an in-game error. on the client, right? So on the client, this will run. On the server, it won't, but the server will run this. So, right? So the server will still bomb out of that and not finish the connection. Okay. So this is this $sign here. This is another newer feature to C#. So this is a string, but when you have a $sign, there's an interpreter that looks for these curly braces, and it will insert variables into your string in an inline insert. I love it. I love it. It's one of the greatest features ever in this language. Okay, so trigger in-game error, not enough items is an actual, I just pulled that right out of here, not enough items is the error code. So I'm sure something is associated with that, not enough items. It I don't know, it shows the jingle, it shows the text and it bounces the text on the screen. It does something. But yeah, it returns, and then else, then we do slot.takeout length, slot.mark dirty. So take out, we're going to take out X number. Because remember, if we get beyond here, right, if we get past all of this, the connection is going to be made. It's too late to go back now. Network ID is associated, add connection, new connection. Now, back to what I was doing. I wanted to get this finished. Trigger add connection, I did that already. Okay, so here we have this. Now, if we get this far, and either of these are wrong, the one instance that I can think of that would cause this is if you were pending a connection, you had right-clicked on a node, and you were in the middle of stretching the wire, and something or one broke that block that you were already connected to. That's one of those cases that can lead to catastrophic crashes, corruption of chunks. Because breaking that block breaks the behavior, breaks the block entity, it eliminates all that from memory. So the start would be null. It would be invalid. I want to I don't know. What do you guys suggest? Anybody have any suggestions on how to handle that? Because if we're in this add connection, if we're all the way down here, ws.now building. Okay. This is a check right here. We're connected to a start position. I want to grab this at the start position. This isn't guaranteed to be the start position, right? We've already gone through now building. Now we have a start position. It's not guaranteed to be the same as this anymore once we're down here. So this is still right. But now we need check start position one last time. Let's do check validity. Check of start position one last time. Because remember, when we click this code is going to run in a microsecond. All of this code is going to run. So I doubt somebody would break a block at literally the same microsecond as you're right-clicking another connection. So before we get into any of this, I want to check the validity of start position one last time before connecting to new next spot. So BE behavior wire BE start equals, this is a long call, api.world.blockAccessor api.world.blockAccessor.get block entity at ws.start position .get behavior of BE behavior wire. Right? Now I need block accessor. I need a question mark there. If this is null, right, means api.world.blockAccessor.get block entity. Remember, if they break that, if you're in the middle of stretching a wire and the block breaks, if somebody breaks it, if an explosion happens, something happens, right? The entity disappears, which means the behavior also disappears, which means this is null. If, oh, that actually already came up. If return. Actually, I want to do even more than that. I want to clear this block wire by entity. Yeah, I want to cancel place. I want to call cancel place block by entity. Block wire as wire. Well, this is a block as block wire. Check validity of start position one last time before connecting to the next spot. So this will grab if there's an entity there, if this behavior exists. If this is null, oops, I don't know why that changed. If it's null, cancel place and return it. Cancel place will automatically reset all these variables and set now building to false. It basically will eliminate the like the pending wire. It'll just switch that off. If the block entity disappears in the middle, that was a bug just waiting to happen right there. That was a massive world corrupting bug just waiting to happen. Okay, so we are now, I think, ready for the last bit here. Add connection. So if we get to this point, I'm pretty confident that start and end exist. Everything is good. The placed wire is valid. We have a network ID. Everything here has run. Trigger connection, everything is good. Yes, I think. I think we're good. So now we need to add beh start dot add wire placed wire wink bh end dot add wire placed wire true. And that is why I like programming, because I've already done all the work for the add wire, right? So you go to the behavior, which of course I closed. Add wire. So wire start. If it's null, then it adds it and appends it. One thing I need to do is where do I mark these dirty? Do I mark them dirty here? Or should I mark them dirty here? Doing that. So you can see when I add a wire, I reset the collision boxes, which, you know, I went through that a while ago. I know this is a long stream, and I know there's a lot of information, but this is the stuff this is what you need to know and do to make mods. Like, there's no shortcuts. There's no shortcuts to doing all of this work. So yeah, collision boxes equals null, mark dirty, which would resync the mod, or resync the data. Now, do I have a remove? Like, what do I do? I've completely forgotten. Trigger remove connection. Oh yeah, yeah, I do that. Remove connection here. What I should do is do this, but pass it in. Yeah, I think I would be. Well, I'll leave this for now. And I just want to get this freaking code working sometime in the next week. At the very least, get it compilable. Yeah, I think that is the last bit. As far as the catenary goes, the wire system goes, the only other thing that I would need to do, most likely, is in add connection. Okay, where is it? There it is. Let's go into add wire. Matter of fact, placed wire is the endpoint. Then I need to say set network ID. New wire dot network ID. New wire. Come on. New wire dot start selection index. Same thing. My God. Wait. Now let's think about this for a second. This will be the last thing I try to tackle on stream here. Oh, stretch first. It's supper time. We look at our example, right? So when we have a placed wire, let's say we place this wire here. Now remember, there's literally, even though these are like coming out of very, very distinct spots, this is one node. This will have one network ID, right? And so the network ID, when we call that event to connect this wire, let's say we run this wire, we click this, it has a network ID, and this will have a network ID because we've already placed these wires. So this network ID will be set. This is why the logic of the network has to go to the network, right? So we connect to this network. Let's say this network ID somewhere over here is 3. Oh my God. Rush, please. Let's say this network ID is 3. We run this wire. This network ID is 5. Now, the logic, again, you can make whatever you want. You can say the lower the number takes precedence. It doesn't matter. But when you connect this network to this network, one of these has to take priority. One of these numbers. Now, in this situation, this network ID is 3. So when we call the connection, because it's called from this whatever node, imagine the node is off screen. The node off screen has the network ID of 3. Right? And then we stretch it across here. So when we fire that event, the start will probably be the precedent, right? The start will be the precedent. And so that means this connection right here will be network ID of 3. So as soon as this is connected, now suddenly this 5 is changed to 3. But I don't care about that. I care about all of these. So as the catenary mod, do we manage the propagation of network IDs, or are we relying on the network itself? That is a big, big question. Because the network ID system, with all of the different nodes, are already going to be tracked. All of these things that are on a network are going to be tracked. This network of 5 is just going to be a dictionary of a network ID, which is a long, with a list, basically a list of blocks or block positions. All of these block positions will have their own list. And so when I fire this event and I say this connection to this connection, and it says this network ID is 3, I need to, as the network, iterate through all of the 5s to turn them into 3s. So I don't care I think I don't care what the network IDs are going to be. Because I'm going to have to iterate through all of those items anyway to set up their network ID, which means iterating through all of the behaviors to set the network IDs. This value here, which is saved and loaded. This is saved and loaded with the game and with the chunk. Override to return the network ID associated with this. Do we want or do we need? Because the endpoint selection index, again, if there's only one item, then the end will be the same. I lost it. Add wire. This will be 0, and we'll set this to 0. But again, I don't know if we need to do this. The set and get network, or the set network ID at the very least, will be handled by the network. Because if let's say you have 2 giant networks on each side. So you have 25 generators on one side and you have 5, 10, 20 machines on the other side. 2 vastly large networks that are individual. And then you run a wire and connect them, right? There's a huge amount of processing that has to happen when you do that. You have to iterate. One of the networks takes priority. Again, when you connect networks, what I'm thinking is just the lowest number, right? The lowest number takes priority. And yeah, so your lowest number takes priority. The lines are linked, they're connected, and you have to iterate through the entire network of the other version, all of the items. And all of the items are going to include all of the nodes in the wire, right? Every one of these is going to be a different node. When you connect a wire on a node, that's going to, if there's no other wires connected to it, the add connection, is going to generate a new network. So the very first time you put a wire, the network is going to be 1. And it's going to set that placed wire to network 1. And as soon as that when I run that connection from A to B and that add connection event is handled, I'll return a 1. This is the network ID I came up with, but I'll already have set those 2 nodes, the behaviors of those 2 nodes, to the network ID. So yeah, I think I've just talked myself out of doing that. The network manager is going to have to do all of that code, all of that work. It would be nice to have the catenary system do it, but the catenary system, again, is a dummy system, and it's not specific to any given network. It's just a generic. Like with a couple different shenanigans, you could create a rope system, right? You could create little anchor points for rope, and then you could just run rope, and it doesn't matter what the network IDs are. It doesn't matter. It's the rope system. Okay, I think. It might not sound like. It might not have angels in the background like singing, but This is a big moment. I think I'm done until I find all of the bugs. and people help me track down edge cases that I cannot think of or I haven't thought of yet. I think the Catenary system is ready to start building on top of. So what I'm going to do is I'm going to delete all of this. This is the Signals mod. I using GitHub. I downloaded a source and I put it all in here just as a reference. Just to try to figure out how he solves certain problems. Like there's a renderer, hanging wires renderer that he does that I don't use because I'm using the on tessellation. So he literally manually rendering all of the wires, right? The hanging wires network, every frame, this is literally rendering all of the wires. And so this is a vastly different way of doing it, like vastly different. Essentially, he has one mod that's tracking all of the wire connections. It's rendering that entire list. So here's the render frame. Rendering this manually, all of the meshes. Yeah. So he's manually rendering all of the wire meshes every frame. And I don't know what he has in here as far as like occlusion culling. I don't see any view yeah, he's got a view model matrix, but there's nothing that excludes stuff. So, and this is really the reason why I restarted, because he hard codes the texture to use when he's rendering it. Right? So, you know, I'm rendering it with a certain block ID. At least I'm hoping I'm doing that. So my on tessellation in my behavior is the thing that's basically rendering it on tessellation. So make wire mesh. Like, is there a texture? Wire start temp mesh dot texture. Texture atlas position. Block behavior wire. Remember, I'm only doing this on the wires, the starting array, right? I'm not double rendering these. I'm not doing the start and the end, because then when it got to the next node, it would do the starts and the ends, and they would double render, and that would be bad. Sets the UVs of this mesh to the specified texture atlas position, assuming the UVs range from 0 to 1 as they would scale in text position. So I don't know. That's one of the things that I was asking Tyrone is, like, what exactly sets the texture ID? And when you look at the behavior and you look at like add beam, see, it sets the block ID, which I save in my, instead of placed beam, I have placed wire, which is where the name came from, placed wire, right? Add beam, this dot beams. So if I do an analyze on beams assigned by, you can see I'm assigning it to add beams. and I am using it from the tree attributes. Again, a lot of this code I used, and then it's read by add beam exchange with. So this is obviously setting the block ID. That changes the texture. Collision boxes, get drops, initialize on tessellation. Placed beam, beams. Mesh data. Get or create beam mesh. Get or create beam mesh. This is just... Okay. This is, I think... This generate mesh, we pass in the original mesh. I don't know why. I don't know what sets the texture. If it's this mesh data that I grab from this, right? Tessellate shape, turns the shape into a mesh data object. Use the given collectible texture configuration as texture source. I don't know what that, like, uses the given collectible texture configuration. Texture source collectible. This right here. Tessellate shape. So I do that. That is the mesh data is an out, so that's a reference. So the mesh data, so maybe this is the thing that gets me the block, the mesh data. That's the texture. So that gets returned here. Now, what do I do? I can't even remember what I did on tessellation. Yes, so I don't call that. From just shrink up some of these. Add wire. Make it easier to navigate. Okay, is that? Okay, so it is in the beam. So it's in the mod, not in this. Get or create. There's the block. Original wire meshes. We have one reference in the catenary mod, line 148. Wait. Oh, okay, that's the workspace that gets that. So now I want, or I'm going to need the same kind of call in the on tessellation. But wire mesh.make wire mesh. So this is this static call. This is where, so my mod sort of branches off of the beam placer. The mesh data, he's passing in to his generate mesh. But the only place that's used is way down here. Add mesh, add the supplied mesh data to this mesh. I don't know what that would do to the mesh itself. Like this code here with render passes. Yeah, I don't know how much or how much I would have to change. Original mesh.clone, transform, mat. Like I none of this code, I have no idea what any of this does. With render passes, with XYZ, with color maps. Sets up the tints array for holding tint info. So yeah, there's probably something fundamentally not working as far as getting the textures to work with this, because I just don't know enough about the rendering side of things. Temp mesh equals. Yeah, I'm probably going to have to really look at this and figure out a way to sort of hack together. Hack together something. I don't like it. Grabs it. So the tessellate shape is using that code, and it's giving me mesh data out. But what mesh is it? It's probably just the default. Yeah, it's the default shape of the base, textured. So it's a very simple mesh, but I don't know why you then have to use that. Why you can't just set the texture? Like, is there a way to set the texture of a mesh? Let's go to mesh data. Let's just see if there's an example of this. This is why I love DNSpy. Texture. Is there anything in here? Set text position. UV. This.uv. Okay, sets UVs of this mesh to the specified texture atlas position, assuming the initial UV. Texture atlas. Let's see if there's anybody that uses this. Used by. Not a lot. Model data, position. Insert texture. Okay. Tessellate shape. That was that call. Tessellate shape. Build mesh data part. Wow, look at that. Look at all this. Like, this is one of the reasons why this code is just beyond me, because I've never had to work with stuff like this. GLTF node. I'm guessing that's yeah. This is some low level like vertex work for the video card. But anyway, I think before I get lost in the weeds here, I mean, at this point I don't know what texture it would be. I have no idea. Like, what texture would this have? So, if we can look at Hanging Wires renderer really quick, I could look at, where is it at? Right in here. Texture ID, get or load texture. So this is manually grabbing the LED texture, bind to texture 2D, and this is the render API. Bind texture 2D to that texture. But if I wanted to not do that, if I wanted to load the texture from the shape, I would have to temp mesh dot. So there's so much stuff in here. Pity there's no like set texture. Texture atlas position. How the world do we do that? Bind texture. Texture atlas position. No idea. Like, is there a way? Lock. We are wires start of I. Oh, actually, we are at wire.block ID. Let's do API dot. Wait, I don't have the API. Dot. It might be like world dot get man. Get block ID dot block material. No, it's not. It's definitely not block material. Shape. Dot texture. No. Base. Oh, that's an asset location. No, that's not. Yeah, I'm way out of bounds now. Dot. I don't even know how to get to the texture. All right. Well, I'm at a loss. So that'll have to be something. I hope that I can get help on to try to figure out the texture that's used when rendering this. As I just make the wire mesh here. Which is different than this. So this has a start and an end. Original mesh slump per meter. I mean, I could copy this entire thing. Copy this entire routine. It's a static. I could actually call it. Yeah, I could actually call it. Mod system support beam placer. I could grab that mod system and literally just call this instead of my routine. And add some. I don't know what's the slump. What would you do? Slump per meter? I have no idea. 0.5 maybe slump per meter. So if it's a meter, it's 0.5 down. If it's 2 meters, it's 1 down. Maybe that's too much. I don't know. But yeah, I could literally call this entire section. I don't even need to copy and paste it. I could literally call it. So rather than do that, if wire.wire mesh data equals null, we need the I mean, yeah, it would be easier to just copy and paste it. So the first thing I'm going to do is dot get or create mesh wire dot block. Okay, that's the mesh. How about we do catenary mod private? Might have to change mod system. Support beam placer. Nice. It wrote that whole line for me. I love it. All right, so this is the behavior wire. Ideally, we would have this in the catenary mod, actually. Let's do it that way. Here, go to catenary mod. Come up here. Do this. I need to include that again. Back. Take this out. Because if I already have a link to the catenary mod, I don't want 50 different links to the beam placer mod. That would be a bad idea. Okay, so start method. Okay, so the assets aren't loaded, but this mod system should be loaded. Yeah, it should be loaded. The APIs and stuff are all loaded. So this should be right. Okay, so with that, go to behavior, on tessellation, we should be able to do cm dot s. Actually, s. What domain did I set? I set it up to private. That's why. cm dot svp dot. Oh, is this? No, it's static. Generate mesh. Why is what? Why can't I call this? Oh, it's static. I don't even need mod system support beam placer dot generate mesh. Just like that. Okay. So I can take that out. And I can take that out. That's the beauty of static calls, is you don't need an instance of a variable. You can just call it directly. Okay, so generate mesh. All right, and then we're going to do, this is a vector3 start, so wire dot start, wire dot end, temp mesh, float slump per meter 0.1, 0.5. Oh, block facing. Oh, shoot. This is not used at all in this routine. You can see it's not used anywhere. Okay. So I don't care what it's start to end temp mesh. Um Mesh data mesh. Okay, so I need to create, instead of doing that, mesh data, new mesh. All right. So these, I had to do a deep dive into these. Murmur hash 3 mod. This is the most insane. I'll end with this. This is the most insane thing ever. Okay, so you look at these. This is I hit this and I was just like, what the hell do we do here? All right, so I was looking at this float XYZ. So hash, if anybody knows out there, if anybody has any programming experience, you know that a hash is like a unique identifier to anything, right? You can hash a movie, you can hash a password, you can hash anything, and depending on the hash algorithm, you can get a unique identifier or you can get a verifiable thing, right? Like a password, when you enter a password, that's run through a hash, a cryptographic hash, or cryptography, I should say. So the same password will always result in the same hash, and it's the hash that's stored and verified as a security measure. But you can hash anything. You can create a like an SHA 128 hash of a file, like a zip file, that's verified. If any byte in that file is different, the hash will be different. So a hash mod, if we go into this, Murmur 3 hash mod, not so fast but higher quality. So I looked up this, gamemath.mod, Murmur hash 3. And I was like, all right, what is Murmur hash 3? Holy Moses, look at this. Fmix, rodal. Look at all these bit shifts multiplied, like crazy. Like, what is going on here? Like, what is this for? Look at these numbers. I mean, look at the size of these numbers at work here. Like, what is going on here? So the rodal, all of these are all bit shifts. You can see these are all bit shifts. So trying to discern what numbers this spits out, nearly impossible. So I was looking at the original. I was like, what could this possibly be doing that that it was needed? Because the amount of math that each call that is done here, the amount of math that's being done is crazy. Like, why would you do that? So I reached out to Tyrone and I asked him, I was like, what the hell do these do? And all they do, the float X, Y, and Z, for every placed beam object, it will have a unique identifier to start, end, and basically the ID, like what block it is. It'll have slightly different starts and ends. And what this does is it generates a very, very, very tiny offset. Very tiny. And this is what this is for. So if you have two beams, let's say you have a block, right? Let's say you have a block, and you have a beam coming out this way, and another beam coming out, but that overlaps, right? So it overlaps the other beam by quite a bit. What those calls do is shift them ever so slightly, so you don't get any Z fighting textures. You don't get any flashy, like really, anytime anybody's played games a lot sees like the textures that flash a lot. So that's all these calls do, is offset very slightly the beams themselves. Like, we're talking fractions, like tiny amounts, to prevent the Z fighting from happening. So I don't need to do that. So yeah, I don't need to do that. We're doing this. Measure.addMeshData. 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 All right, so here we go. Wire start. Okay, this can go into here. Wire start on mesh data equals new mesh.clone. Because if mesh data is wire mesh data is not null, then we're just going to use that. It means we've already generated it. Now the other place we need to use this is yes, in the end offset. There it is. Or not. It's on render frame, I think. No. Reload mesh ref. There it is. I knew it was in here somewhere. The thickness, that's one thing that I don't have control of right now. Doing it this way. So yeah, I don't have that ability just yet. I would have to copy it, and I don't even know how I would do that, but this here mesh data current mesh equals WS current mesh. Let's see. Do I need to get or create? Let's look at the beam placer. Mod and its version of not on tessellation, reload mesh ref. I'm clicking on all the things. Block facing. Mesh data. Mesh ref. Okay. If mesh ref does not equal null, dispose. This is an important line. So this is reloading the mesh reference. This for some reason is not setting current mesh. So is there an initialize? Where does this get initialized? Current mesh. Because what if this is null? What if current mesh is null? assigned by on interact. Aha! There it is. Current mesh. Okay. So on interact, there it is, current mesh. Excellent. So that's already done, which means the reference here, I could basically do mesh current mesh and then mod system support beam placer dot generate mesh of. Okay. Start offset, end offset, null, because I don't care. Current mesh, thickness, that's funny. Slope from 0.5. This is going to return another mesh, so we need another mesh data. Okay. Attributes not equal null, attributes okay, that's the new mesh. Current mesh equals new mesh. Current mesh ref equals upload mesh. That gives you the mesh reference. It's basically a pointer onto the video card. Something you don't want to really mess too much around. But we're uploading this mesh. We're getting the pointer back. That's the reference. That's what we dispose. But we're saving in the workspace the mesh. And I hope to God that that also includes the texture information. I hope. I really wish it would also allow me to set the thickness. But in the end, if the shape defines the thickness, then I'm okay with that too. Because then I could get rid of the whole thickness thing out of there and just rely on the shape. The shape gives you the thickness. That's fine. I'm fine with that. But now this is attributes, thickness. I would just ignore that now. Current mesh. I just want to. I want to use some code that works. Hopefully works. This should generate a mesh from start to end. The facing isn't used at all, so I'm fine with that being null. And the original mesh, I think that is where it gets the file or the texture from. I think, I don't know. Slump per meter, I'm setting that, and that can be tweaked, of course. Maybe I'll change thickness. From the JSON file, maybe I'll change thickness to like slump. Right? The higher the wire tier, the less slump it has, so you can run them longer. I don't know. That value will have to be tweaked at some point or changed into JSON. I don't know. Whatever. Anyway. All right. Well, I think that at the very least will get me get me started and get me down the road to at least. Wow, yeah. Crazy. Get or create mesh, where's temp mesh? If I am, I should. Oh, wire.mesh data equals null. I'm gonna put all of this in here, right? If the wire for some reason loses all of its mesh data, then regenerate it. Otherwise, use it, right? Otherwise, use it. But this will set it. This will override it if it's null. And then this will use that new generated one. So, all right, I think I can delete all of this. Wait. And that, my friends, is the Catenary mod. I think it's good. We don't need the wire renderer anymore. This is something we can get rid of. Catenary mod, block wire, behavior wire, wire tool, behavior wire. Placed wire, wire block, wire mesh. This I don't necessarily need. This is the static make wire mesh. But again, I may want to customize this somewhere, sometime, at some point. I don't know. So I'll leave that in for now. Wire node, I don't even know as many places. Where does this get used? Oh, a lot of places apparently. Okay. I guess I'm using this in a lot. Like, I don't even remember. Behavior wire tool. Wire node. What? What? Why do I have this? Why? What? I don't think I need this wire. Where does this wire node come from? This was kind of a carryover from the hanging wires mod. That's the wire node itself. I don't need. Yeah. Get anchor position and block. Wire node. I think I need that to be a wire anchor. Anyway, I may have a couple things. I don't think I need this wire node. I just don't think I need it. Because this is too generic. Block position and index, that is not enough information. Like, that's nothing. The 15 references is mostly from the node itself. An electric node, electric node. Again, none of this stuff is fleshed out yet. The specific stuff. The specific stuff is not fleshed out yet. So I haven't done any of that. But yeah, I'm pretty sure that I can just delete the wire node. I don't think I need this at all. Because I have the generic wire anchor. Right? I mean, yeah, this has a bunch of IEquatable stuff in it, like IEquatable. So there's strings and a bunch of stuff in here for equality. I don't know. I'll leave it as it is, but for now, that's going to do it for the stream, everybody. Not sure what we're going to be streaming on Saturday. There's a couple options on the table. I'm looking at either something simple and easy, like and free, like Open Transport Tycoon, just to play around with multiplayer. Might be interesting. Or it's also been sort of floated as getting into some modded Ark. We haven't played Ark in forever, like years. And I know there's a ton of mods for it. Playing it last time, it would be good for at least a month, a month worth of streams. But anyway, yeah, something. We'll stream something. Let me know. As always, if you have suggestions or comments about games to play, whatever, for streams, always let me know. If you have any questions or comments regarding today's stream, don't hesitate to ask. And please hit that like button if you are at least trying to learning something from these streams, or in support of the mod itself, and consider being a patron. Of course, the more support I have, the more likely the mod is to get done. Takes a lot of work, so consider being a patron and supporting the channel and the project in general. But anyway, I will see everybody on Saturday.